Yo, 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 what up, chat? Good morning. Good morning. Scorpion, what's up, dude? How's it going? Aramis, hello, hello. Good morning. Tanny, how's it going as well? Hello, hello. Marvin, what's up, dude? Welcome, everybody. Hello, hello. Good day, good day. How are we? Yo, Cowface dude, what's up, buddy? How's it going? Thank you for the 11 months. Don't make me use Rust 2. Using Nix is hard enough. Don't worry, we're going to talk about why I'm using Rust today. Because I think a lot of you guys are going to be like, whoa, BG's using Rust? Why? Don't worry, we're going to talk about it. We're going to talk about it. We're going to talk about it. Thank you for the 11 months, though, Cowface dude. I appreciate that, buddy. And you should use both Nix and Rust together in harmonious matrimony. Murano, how's it going? Hello, hello. What's up? I was on a prod issue call for 5 hours East Coast time. Oh, dude. Listen, I have been here. I've been there. I was there like a week and a half ago, my friend, okay? I feel you. I wish you the best of luck. I hope, if anything, you're at least chilling now, my dude. What's up, Godwo? How's it going? MDS Ubuntu, hello, 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 welcome everybody. Hi, how are we? Sheer, what's up, dude? How's it going, buddy? Hello, hello. Aramis, I'm doing good, man. How are you? Because Rust is your savior. Technically, no, Nix is still very much my savior, but you know, Rust might be a new one in the tool belt. We'll see. I don't know. Right now, it's a like Rust and like Haskell and like Scala and like these more like I mean, Rust isn't functional, but I'm saying that these more functional programming languages as well are also very interesting to me right now. So, oh boy, I'm doing good though, Aramis. I'm good, buddy. I'm good. Yes, I remember your Circle CI theme. At least it was not a weekend for me. Yeah. Circle CI thing sucked. It sucked so much. Oh, God, don't remind me. How you doing, by the way, Marvin? It's good to see you, buddy. Hope everything's well with you. Tani, it's been a minute since we've seen you, too. How are you? Hello. I only get 5 minutes in a work call. Oh, shoot. Well, I hope we get to enjoy each other, at least for the next 3 minutes. I had to tell people at my work, I was like, all right, you know what? I'm just going to let everyone know when I'm on a work or when I'm streaming. Then nobody has to ask where I am. So that's kind of how it works now. I just send out a message to everybody and I'm like, hey, I'm streaming. I'll be back around noon. Talk to you later. Been a long time since I've been able to get one of those. I've been having real shit at work with C++. Writing Rust and Go in my free time is more fun. Trust me, my friend. I have been there as well. There, like that's the catch. That's like the flip side of DevOps is if you're at an organization where you really enjoy in the languages that they use, then you'll probably enjoy yourself. Whereas if you're at an organization where like it's all languages you hate and you don't enjoy supporting, that's kind of rough too, man. That's definitely kind of rough too, to say the least. I'm sick but feeling better. Well, I'm glad you're feeling better. I'm sorry that you're going through a sickness, a cold of some sort. Down with the sickness, we could say. Oh, God. I'm sorry. Listen, I was born in a time where slapstick comedy was fun. Had an amazing vacation though, so I'm happy, and with that, work is calling. I'll try and be back later. Yo, Tanny, thank you so much for hanging out. Good luck with your work call. As we like to say at the Alta 4 stream. At the Alta 4 stream, we don't actually say good luck. Do you know why? Because I'm a nerd. And I used to work in film. And so we say break a leg. So Tanny, break a leg. Good luck. Break a leg. You know, break a leg, whatever. Gannett, how's it going? Hello. Gan, or is it Gannett? Hello. All right, guys, so check it out. Let's talk a bit about, okay, hold on. Actually, let me open up Notion here because I want to write a document. 1 second. Okay. So check it out. Again, it's fine either way too. Okay, cool. Are you going to work through it? Are you going to work through a TDD? Kind of. I mean, I already know what I want to build, but I'm going to TDD it for you guys so that you have an understanding of what we're building too, right? And so what we're going to say is what we want is an atomic build build configuration generator. Right? So what's our problem, chat? This is how we do things here, chat. Yo, what's up, Sedman? How's it going, buddy? This is how we do things here, chat. What is our problem, right? Here's our problem. We maintain a large amount of repositories which all contain very similar build configuration files that require us to manually update these files when changes occur, right? The Circle CI plus stuff generator. Yeah, that's it. Yeah. And if we wanted to, we could even just say build configuration generator, right? So the problem, chat, that we have here is we maintain a large amount of repositories which all contain similar build configuration files that require us to manually update individually when changes occur, right? So what does that mean? What does that mean, chat? Well, let me show you an example here, right? And this is really going to be our first target example, which is actually here, let's go here. Pulumi. If we go to the Alta for reposits where everything is, actually hold on one second. Hold on. Ooh, I'm glad I didn't do that. Cool. Okay, sorry about that. So if we go to the repositories for Alta 4, you'll see that we have a common trait between some of them if I search for like the word Pulumi. And the big one here is that we have a series of repositories that are all focused around Pulumi automation. So like Pulumi GitHub, Pulumi machine user, Pulumi container registry, Pulumi bucket, right? Pulumi Kubernetes, right? Like all of these different repositories are really just at the end of the day Pulumi repositories, but they all have separate, so Pulumi Q, Pulumi Power DNS, oh, that's actually something else. But Pulumi DNS is Pulumi Network, right? And you can even kind of tell where the separations of concerns are, right? So if we go back to our document here and we kind of fill this in, for example, what do we have, right? We maintain a series of repositories that let's say that have similar aspects in their goals, such as, right? And again, that's going to be Pulumi. What's another one? So let's see here. So Pulumi is going to be a big one. Oh, come here. We also have Quirk related projects. What else do we have? I'm trying to think. Actually, here, let's just go look at our repositories. Actually, a lot of it's really just Pulumi stuff, which will help no matter what. Let's see, what else do we have, though? Actually, you know what? We should add to this as well. So VPN, Quirk. Actually, here, we can change this from Pulumi. We have services, right? That's a lot of what we do, to be honest with you. Let's see here. At some point, we are going to have to maintain open source, like build pipelines and stuff, but we don't even have tests around that yet. So I don't really want to care about something we don't have yet. The Circle CI, well, that's going to be a part of it. So let's talk about that now, right? So when we talk about Pulumi and what we have, right? If we go to like Pulumi GitHub, for example, right? Because remember, what we're trying to solve, Calface, dude, is we're not trying to solve like individual templates. We're trying to solve concerns that we have as an organization when it comes to like repositories that we care about, right? So for example, here, can I zoom in? Okay, cool, I can. Noise. There you go, chat. There you go. Look at that, you blind mother. I'm just kidding. I'm blind. All right, so here, for example, to give this a little bit better clarity, we have like Pulumi repositories, right? We have like Quirk. This is where stuff will get a little bit more interesting, actually, because now I can actually show you the separation, because Quirk does have a lot of different types of repositories. So Quirk Pulumi service, honestly, that's still a Pulumi repository, right? But like Quirk front-end portal, that's something entirely different. So if we say like Quirk front-end, right, then that means that we have a specific types of Quirk front ends that build a specific way, right? We have Quirk backend, right? So Quirk backend, right? That's a specific type of service that we build, right? Here, we'll put these back together. Quirk worker. Dude, I like this song. I'm jamming. Cron. I don't think we do a cron anymore. No, we do cron. Wait, do we do crons? I don't know if we actually do crons. Cron worker, right? Or Quirk worker. Sorry, not cron worker. So Quirk Docker node. Docker node, what would that be? That would just kind of be like a Docker, a basic Docker one, eh? So like, so if we like try and maintain Docker specific projects, right? So Docker specific projects, right? Docker node, Docker Nginx, libraries as well. So we've got Quirk libraries too, right? And don't worry, this will make more sense once I like get into it. But you guys are starting to see the actual patterning that I have created when it comes to organizing my repositories. If that's what you were to ask yourself right now, if you're saying like, what are we looking at? What you're really looking at is how I've logically organized my repositories, right? And so technically, if we really want to kind of break that down a bit further, it's like Quirk, right? And then within Quirk, we have front end dash, right? And then we have back end dash, and then we have library equals, and then we have worker star, right? And again, the whole idea behind this is that I am using a standardization of naming to be able to organize my repositories so that I understand what exactly they do, right? And so now I know that, again, everything with Quirk in front of it is a Quirk repository, right? Everything with Pulumi in front of it is a Pulumi repository. Everything with Docker in front of it is a Docker repository. Yeah, thank you, Cowface. I appreciate that, buddy. So because like honestly, if we're gonna build this thing, I want to use it everywhere. You know what I mean? Like if I'm gonna build this tool, we might as well try and have it solve for as many problems as possible. So we're really trying to understand all of the different types of repositories that we have, right? So again, we've got Docker ones, we got Quirk libraries, which we have here. We've got Quirk workers, which we have here. Oh, we don't have crons. Again, I don't really know if we have crons in Quirk anymore, which is like shameful to say because I built that project. But I actually don't know if the cron. Oh yeah, calendar notifications. Okay, yeah, we still use crons. Never mind. Yeah, we do. We have backends, right? We have bots. Oh, we forgot the bot. So here, let's move backend up to here. We forgot bot as well. There we go. Dude, there's a lot of like service types with Quirk. Quirk is a beast, man. It's a project that's going to like rise from the ashes as this like beautiful phoenix. I believe it. I know we all say that about all of our projects, right, chat? I swear once I get that project done, it's gonna be awesome. Happens to the best of us, don't worry. Even I deal with it. But it will be, all right? It will be. I believe in us. Bot, worker, cron. Again, these are Pulumi. So again, the Pulumi. So here's what's neat too, Chad, is like if we try and say like this is a Pulumi repository, then technically this can use the same as Pulumi dot, right? So that means that this template is actually already solved for here, right? It's just a Quirk specific. And you see how that reusability kind of comes in play. Don't worry, like I said, we'll go into more detail on this, but hopefully you can kind of understand, at least see the kind of software we're building, right? Pulumi component, that is a library. So technically that Pulumi component is a library as well, meaning we should probably rename that, is what we should probably do. This should probably be like Quirk library Pulumi, because it's a library for Pulumi. Backend, worker, backend, bot, front end, Pulumi service, Quirk SDK. Okay, that's all the Quirk stuff. We're not going to worry about any of that stuff. Pulumi GitHub, Pulumi machine user. Again, that's under the Pulumi category. We've got build configs. Should we have a template for the template generator? I don't know if I actually don't know if that makes sense to have one for that, because this is what we call a snowflake. Like it's unique, at least for now. Container registry, bucket. That's my presentation, so we don't have to worry about that. On-prem Kubernetes. That is Pulumi automation. Yeah, so that's actually Pulumi. Ansible automation. Holy. Okay. I don't know if we're going to use Ansible going forward, but there is a solid chance that we could have Ansible automation as well. However, all of that Ansible automation that's sitting there right now is dead, because we don't have, like, basically on-prem Pulumi and on-prem Ansible we don't use those anymore, essentially. So I don't really know. Yeah, let's not use it right now, because again, everything's in the cloud now. Symfony, like build configs, is its own thing. Recording pipeline Pulumi. So again, that is a Pulumi repository, just like Quirk Pulumi, right? And so that's fine. Recording pipeline publisher. So we do have recording pipeline stuff as well. Recording pipeline. And we really do need to consider the recording pipeline, because it is such a tool that we use. So we have Pulumi, right? Just like we did before. And remember, we said that same type of repository will just have a reference back to this main template here, right? So this is already done. Technically, just in our design alone, we've already solved for recording pipelines automation template for Pulumi, because we solved for it here. So that's pretty cool too, that we can, and we actually, and for Quirk as well, right? We're already seeing value in this by being able to reuse these. The publisher, however, that is a node service. Would it be a bad idea to use Ansible to bootstrap Nix? Yes. Yeah, it kind of defeats the purpose of it. I have one project I keep coming back to and changing and working on. I still need to make some progress on one of these days. One of these days. Don't worry, you'll get there. I believe in you, buddy. Like I said, I'm still going to build a cloud platform. It's just, we'll get there. A Symfony will rise again. Maybe we'll work on Symfony this year. Although we will build Symfony in Go. I'm not going to build Symfony in like Rust or something like that. That would be insane. Cool. Okay, so we have a lot that we can kind of already take care of from an automation standpoint, right? So let's look at this really quickly, right? So again, our problem is that we maintain a large amount of repositories which contain which contain here we go. Sorry, chat. I'm working on my grammar a bit. We maintain a large amount of repositories which contain similar build configuration files that require us to manually update individually when changes occur, right? And we could just say build configurations that require us to manually update each individually when changes occur. There we go. And so, when I first started this, we just said like, okay, well, we have a bunch of Pulumi repositories, which is true. But once we dove a little deeper and we said like, okay, well, what kind of naming conventions do we have? We recognize that there's actually a lot of repositories that we have conventions around. Like all of Quirk's build configurations could become automated. Where if there's a Circle CI change, or if I'm like, dude, think about this, chat. If I go, you know what? Going forward, I'm not using Circle CI anymore. We're done. It's over. I'm kidding. Like, I'm not being serious about that, right? But, if I was to make that decision, then all I have to do is make the build configuration generate a new file for the new pipeline, platform, and then start managing that file, and then just remove the old one. You know what I mean? And so again, like this literally can save you so much time, right? And that's why we're kind of looking at this. Would it be a bad idea to use... Oh, wait, no, I already answered that. What do you need to bootstrap in Nix? Yeah, I mean, that's kind of what Nix is for. Is it Kuya? Kuya, I think? Hello. How's it going? If I said your name wrong, I'm sorry, by the way. Pasha, I think. Hello as well. Okay. Cool. Mao as well. What's up? Hello. Grapefruit. Hi. Okay, cool. So let's do this. Let's look at Pulumi first, since that was going to kind of be like our main focus to start, right? So let's do that. So we're going to go to Pulumi GitHub, and we're just going to take a look at the repository and see what's in it, right? So let's look at the root first. Well, we have a circle CI, a circle, geez Louise, I can't spell, CIR, CLE, CI, there we go. We have a circle CI directory. We have a git ignore, right? We have a Docker file. We have a README, but that's going to be unique. So again, what we're also trying to do is we're trying to focus on files that can be shared, right? So just simple name changes or stuff like that can be shared. And technically, if we wanted to, we could just say circle ci config.yaml. Git ignore, Docker file, index.ts, no, just file, yes. Package.json, tsconfig, tsconfig. So here's the thing, chat. If we say something like a tsconfig is a part of it, then we're kind of making an opinion that this thing can generate for a specific language, which right now I don't want to couple a language to this. I really want this only to be build focused. Now, as I said, I use this at work, so I build this at work. Like Avi and I built this together for Hippo like many moons ago. So I manage this kind of thing at the company. I'm very aware of its power and what it can utilize, and kind of also where its bumpers are. Because at Hippo, we are such a node-focused company. We build a lot of stuff in JavaScript and TypeScript and stuff like that. There are things like jest.config.js and things like that. I leave that up to you. Right now, I'm not trying to at least add any type of language support. Now, however, that doesn't mean that, and we can start kind of talking about this, for example, is we can say, well, oh gosh, come on now. Is this 1, 2, 1, 2, 1, 2? There we go. What do we have? And what we're going to call is our centralized configuration, right? Or a repository configuration, right? And the idea here is that we need a way to provide developers and again, I'm the developer in this case, developers the ability to configure repositories to with build configs to generate the desired template and template configurations, right? So we need a way to provide developers the ability to configure repositories with build configs to generate the desired build configurations is what I tried to say. My bad. Holy smokes. What's up, Snow? Hi, Snow. Hello. How are you? Happy, is it Wednesday? Yeah, Wednesday. Happy Wednesday. Hi, happy Wednesday. Welcome everybody from Snow Cone Stream. Hello. Shout out to Snow as well. If you guys don't know, thank you, Atoda. literally got to it before me. How was your stream? Sorry, I zoned out for a second because I'm still waking up. But how was your stream? Hello. Hi, everybody. Chebby, hello. Snowflakes are falling into chat. Oh, that's so cute. LW Killer, what's up? How's it going as well? Hello. My lunch is over, so I got to skip immediately, unfortunately, but hope you all have a good, are all having a good time. Oh, Checksers, thank you so much. I appreciate that. Thank you for hanging out. I hope you have a great rest of your day. Thank you for being here, my friend. Remember our career discussion? Microsoft just announced they'll have it in the next 2 months. I got to interview prep base. Yeah, the time is no better than now, Snow, and you got this. You know, as I said before in my rant, I'm not going to start screaming right now because I'm tired. I almost, like, literally, for like a split second there, I was about to go to 10, and I'm not kidding. My brain just went, nope, we're not doing it. You don't have enough coffee in you yet, BG. I can't. Oh, okay, there we go. That's all I got. That's all I got. If I scared you, chat, well, good morning, and blame Snowcone for that one. Maxwell, thank you for the follow. I appreciate it. But no, good luck, Snow. Seriously. Or again, as we like to say, break a leg. You'll do great. Let it all out. Yeah, that's the first morning yell. How's your stream though? What was you up to? Okay. What's up, Will? How's it going, man? Thanks for scream. You're welcome. You're welcome. Like I said, oh man, it's like so. Like the easiest way I can describe it, it's like the game at like a fair or whatever, where like you hit the hammer down and then it like blasts the little thing. Like I was just able to get that thing up there for. Like okay, all right, that's that. All right, we're done. Yep, that's it. I was doing a get ready with me for work. I gotta drive. You gotta drive where on another now? On another? Wait, do you mean you have to drive for an hour? Yeah, drive safe. Don't talk to me while you're driving, Snow. Okay? Oh man. Oh, on over. Oh, okay. Okay. I was like drive on. Okay. Thank you, Snow. I'm slightly nervous that you are now driving while watching the stream. So I'm gonna let you go. Okay, you enjoy yourself. Have a good day, and thank you for the raid. I was about to roast you for not reading well, but then I wrote it wrong. Yeah, no, you did. That wasn't me. That one was you. That one was you. But that's okay. It's okay. Please just drive safely. Have a good rest of your day, Snow. Thank you so much for the raid. Welcome everybody, by the way, from Snowcone Stream. Hello, hello. I am BG. I am one of the co-hosts of the Alta 4 stream. Basically, I am a DevOps engineer. I've been in this game for a little while now. I just hit my 10 years, like probably about a year ago, almost a year ago now, honestly. But I've been in DevOps for the last 4 years. It's something that I'm super passionate about. I like being somebody who has an impact at an organizational level. Somebody who can make changes that impacts a lot of people. That's something that I enjoy doing. Yeah. And so that's kind of why I do my job. And so one of the things I'm showing you today, now here's the thing. I'm going to be real with you, chat. You guys are getting a sneak peek into a course that I created on Front-End Masters, actually. If you guys don't know, if you haven't heard about it, I did my first ever Front-End Masters course for DevOps. And it was very focused on educating you on what DevOps really was from ground zero. I don't know if they've actually put it out yet. No, they haven't actually put it out yet, but that's a link to the actual workshop at least, so you can watch it if you have one of the Front-End Masters subscriptions. But yeah, no, it's a really, really good workshop. I took a lot of time into the first half of it is just entirely theory. It breaks down why we do what we do, how we solve problems the way we do, and really kind of gives you a crash course into what the mind of a DevOps engineer is, and how we solve problems. And again, I do want to say as well, I am focused on also becoming a principal engineer. It's something that I'm working towards actually at Hippo. And a principal engineer is basically just like a step, or it's actually 2 steps higher than my current role. Overachiever. But yeah, no, it's something that I'm going for just because I already do this at Hippo. And it's gotten to the point now where, you know, my manager is basically like, dude, like, do you want this project? You know, and I'm like, yeah, sure. So it is something that I'm working towards. I do believe that my passion is, again, being at an organizational level and thinking about it at, you know, across the whole scale. I really do. I can't focus on one thing for too long. It's difficult for me. Yeah, and it's been like that for a long time. It's one of the reasons why I didn't do well in school, believe it or not. No, I don't have a degree. I was just about to say I actually don't have a degree. I dropped out. But yeah, is an architect principal? I don't know. So basically, you've got senior engineer, you've got staff engineer, and then you've got principal engineer. Well, it depends. I mean, that's kind of the roles. And so, yeah, it depends on the org for sure. But the org, normally, it can go from like junior, normal, senior, so senior, staff engineer. There might be something between staff and principal, and then principal. Architect, I think, is just another word for principal. I'm not too sure on that one. Normal. I mean, I don't know, what else do you call it? You like, I was a normal, like, whatever. It's the normal role. What the do you call it? Okay, you tell me. You generic, regular engineer or mid level. So I feel like mid levels actually, when I say like a normal engineer, what I mean by that is that you wake up, you do some programming, you're not really connected to the community or to the, to the culture of it. It's just a job. And like that to me is a normal programmer. Like people who are like above that, I feel like are people who are like, maybe trying to get higher level careers, or trying to like move more forward in their career. Like, again, being an engineer is like at any level is not a bad job. Like I'm gonna be real, like I think we can all agree on that. I would much rather be doing this at any level than some other things out there, so I'm thankful for whatever role I have. But yeah, here in my org, they go from staff to architect, so I guess it's the same. Yeah, exactly. Yeah, like I said, there's a couple steps between senior and principal. Normally, it can be staff, it can be lead, it can be architect, it can be whatever. But again, my job as a principal engineer is to basically be the glue to like two different departments, essentially, right? Like if I was a principal engineer for I don't know. Well, I would just be a principal engineer, but then I would be focused on like a specific thing. Like, how do we meld IT with DevOps better? Right. And then I just like work on that. You know what I mean? For like a year. Right. And then after we've glued IT and DevOps really well together, you know what I mean? Okay, now let's glue. Like, that's literally like I'm like my job as a principal engineer is just literally to glue. That's, glue the pieces together. And so like even what we're building here, this isn't a bad thing, right? But like in a lot of ways too, this is only really focused on DevOps, right? This is focused on like none of this would be user facing, I guess is my point. And a principal engineer normally tries to think of like everything, you know what I mean? No promo code or anything. No, not for that. I wish we had a promo code for ZSA. That'd be nice, but they don't really do that. They don't really do that, unfortunately, or at least not that we know of. ZSA, I'm gonna be real with you. I think ZSA and like Ergodocs and stuff is they're a little bit more I don't know. They're more in-house, I guess. Bye, Snow. Thank you so much for the raid. I appreciate that. In corporate, usually senior is the entry position where you begin working on projects. Everything before that is basic perk for. Yeah. I don't disagree with that. Like I said, I again, that wasn't meant to be rude. Normal is not bad, okay? It's not bad at all. Have I ever heard of a tool called Nextthink? No, I haven't. Do you have a link? Share links, please, because I like links. But yeah, that's what I'm going towards, basically. I'm going towards becoming a principal engineer. So anyways, long story short, getting sidetracked there. We are trying to, and this is something I do quite often with you guys, is I try and sit down and show you from a DevOps perspective, like, how do I solve problems, right? And not only that, like, how can I make it so that I structure my mind in a way where I'm not like getting distracted all the time while trying to build something, right? If you know what you're trying to build before you build it, it becomes a lot easier to build, more so than just jumping in and being like, hey, blah, 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 you know what I mean? And a couple of the things I'd really like to do is I'd like to figure out like what files we want to maintain. I'd like to figure out potentially the configuration options that we need, and then we'll jump into, actually writing code. It's the most IT tool ever. Oh, okay. Yeah, send me a link. I'm looking to get some time. I'm looking to get one. What are we talking about, Aramis? Sorry again. Oh, for these. We can reach out. Toda, can you make a card, please? Can you make a card in Linear to reach out to ZSA? We can reach out to them. I mean, dude, here's the thing, Aramis. I'm gonna be real with you. I am the only person on stream. Oh, you did send it. My bad. It was because it was highlighted. I'm the only person that I know. Besides, no, Manny. I should not. No. Oh, and Melky. Okay, no. Jeez, I'm an idiot. I shouldn't say that. There's so many people who have Moonlanders now. I forget about that. All right, so Manny Moki. Shout out to Manny, fantastic streamer, very good designer as well. I should say amazing designer. I should not short him. He's an amazing designer. Manny, Melky as well. And then us have Moonlanders, us three. So like we're scarce, you know what I mean? Are you okay today? Brain farting like a champ. Yeah, I kind of am brain fart. I'm tired, bro. What's up, Fester? How's it going, buddy? Good to see you, man. Seriously, good to see you. I also like my Moonlander. Oh, hell yeah, nice. Well, I'm glad you do. TJ. Oh, TJ has a Moonlander? I didn't realize he actually had a Moonlander. That's cool. Jordan technically has one that we need to buy from him that he was gonna put in an oven. And so I told him that. Have I seen this? Have I seen what? Oh, I got your next thing, by the way, Link. I'll take a look at it later. Interesting. Actually, I'm looking at it right now. Interesting. Whoa. Dude, look at this thing. Oh, it's just a Moonlander. I mean, it literally looks like a Moonlander. It looks, I mean, yeah, to be fair, it looks a lot like a Moonlander. Although I will say this, it's slightly interesting. Am I like zoomed in a bit? No, I'm not. Oh, that's weird. Why am I like that? Oh, okay, whatever. You know what I will say, chat? It's slightly interesting because they don't have a thumb cluster. Like they do, but it's stationary. I wonder how valuable that is. Because I'm gonna be real, like I don't really move my thumb cluster, but it is like justified, you know what I mean? So honestly, it doesn't look like a bad keyboard. Very cool. Yo, what's up, Hayden? Thank you for the 31 months, dude. Oh my god, 31 months. Thank you so much, man. How's it going? Hello, Hayden. This is my Moonlander. I love it. Ooh, look at you. See, that's what I need to do. I need to get some nice keycaps. That is, oh, come on. That is definitely something I need to do. Come on. There we go. That is definitely something I need to do. Yeah. That's nice. Oh, those are cool. I like that. I like the thumb keycap. Wait, what did you... Oh, you took off the, like, launch pad buttons. Oh, MB Deal, you just ordered a Moonlander? Hell yeah, dude. I hope you like it. Seriously, I really hope you do. If you have any questions about it or anything else, please let me know. Seriously, if any of you guys have any questions about it, please let me know. I didn't know Teach had a Moonlander. That's crazy. +1 for the Moonlander. Try to kinesis like Prime, but no Moonlander all the way. So listen, dog. Like, I'm not going to say that the Moonlander's better. The Moonlander's better. But listen, I just think that if you are a bit more of an aesthetic person, you might like the Moonlander better. And the Moonlander's better. No, I'm kidding. Wait, Prime be talking, man. I feel like sometimes I got to come out swinging just to be able to defend my little keyboard here that I love. No, but seriously, I actually do want to try the 360. I'm very interested in giving it a shot. I think I can't argue about concavity, which I know is a big reason to use a lot of Kinesis's products. I am interested in trying the Kinesis, I will say. However, I mean, it's just such a pretty keyboard. Like, you know, like I just... I've got that side of me, you know. I've got that, like, I'm slightly nerdy and I want things to glow. But again, I will say the Kinesis 360 does look pretty nice. Are you happy with that keyboard, or are you going to go back to a normal one? No, I literally can't use any other keyboard half the time. Yeah. It's a more expensive Moonlander, to be honest. What, the Kinesis 360? Is that what we're talking about? That is a lot of thumb. Is that all thumb? Yeah, that is all thumb cluster. Yeah. What's up, Bear Noper, by the way? How's it going? I got to finish my second dactyl before work from office starts. Wait, what? I got to finish my second dactyl before work from office starts. So you have a dactyl? That is another one I've wanted to try as well. Yeah. I know that, like I said, yeah, you guys said Tej has got one, I believe. And those look pretty cool. But yeah, I'm happy with my Moonlander. Yeah. I want Lunar Lanther though. But my mobile Lunar Lander though. But my mobile will be what? What? What's up, Rudix? How's it going? Props to Razer for being one of the first ones to do mini keyboard. Oh, that's a bit old school. That thing's been around for a while. What's up, Rorix? How's it going? How long does it take to get used to the Moonlander? I mean, to get used to it seriously, it took a while. Yeah, like let's do a quick monkey type. I haven't done a monkey type in a while, so let's do one. I'm probably gonna fail. All right. I'm too tired. I haven't woken up yet fully. Actually, that's still not bad. So, like, one of the big things that's really important to point out for the Moonlander is you're gonna get, like, this is gonna improve no matter what. Or sorry, your accuracy. My accuracy is always 95% or better. And you might be like, BG, how's that possible? Like, what do you mean? So when you're on a normal keyboard, you do a lot of cross keying. And the idea behind that is like, you probably like, cross over here, cross here, put a finger in a place where, where it shouldn't be. Phrasing. With a split keyboard, you just can't do that. You know what I mean? You just really cannot do that. It forces you to really make your hands stay stationary as they should be with the keyboard and just type. And so even though my words per minute is still like my words per minute before using this, my words per minute before this was probably average like 120, 115, something like that. But my accuracy was crap. My accuracy was like 86%, 85% or something like that. And so to be able to have high accuracy as well as high words per minute doesn't mean you're just typing fast, but it also means you're typing accurately and efficiently, essentially. The only person I've seen destroy both of these, by the way, is Tej. Tej is insane when it comes to typing. He's like a friggin' composer, dude. He can type very fast. I challenged him one day on stream, and then he was like, okay, and then he did it, and I was just like, holy. Yeah, no, Tej is a very, very good typer. So any suggestions he gives you on typing, I highly recommend. 100 words per minute, 97. There you go. See, that means that you've got really good accuracy as well, right? Like, and the lesser errors means that again, you're accurate basically. Here's an idea. There's an API to this next link, and I personally know the company that paid top for food for thought. Okay, Gabs, I think you're just trying to sell me a product you want me to build for you, bud. Just so you know, there's tons of money sitting right here. All you have to do is spend a ton of time building it. I'm just kidding with you, man. It does sound interesting. Like I said, I do have the next thing sitting up here, so I'll take a look at it. How is that keyboard for gaming? Oh, it's awesome. I just literally do this. Bam. Because it's split and it also is detachable like that, it's really nice. You basically have a left cluster. I play a lot of like FPSs and stuff, so yeah. I normally only use one thumb cluster or one keyboard pad, I guess is what you call it. I'm just a Keychron basic pleb. Dude, Keychrons are great. I've got a Keychron. Look. The Keychron for me is it's a portable. It's like what I talk to. It's what I use when I'm like on my iPad and stuff like that. That thing is super nice. I'm just not as fast with it because I'm so used to my split keyboard. Is there a redeem 50 push-ups that way? No. Maybe in the future. There used to be, but honestly, chat destroyed me one day and I was just like, nope. We're not going to allow chat to DDoS my body in any kind of effective way. I remember that at some LAN parties. Damn, chat, watching BG use a normal keyboard is funny. Yeah, it's pretty bad. You should always stay above 90%, otherwise you just lose time correction. That's not wrong, Marvin. You're not right, or you are right with that. What's up, Parkour Peter? How's it going, buddy? Hello. Next thing looks like the embodiment of a corporate software. Maybe this is just guerrilla marketing. It could be. Always focus account first. Building speed when you have account is easier, or accuracy easier when you're already fast. Yeah. Yeah, that one's a K3. Yeah. You're good, dude. You're good. Cool. All right. So chat, as I was saying before, before we started talking about job roles and keyboards and stuff, man, you nerds, we just go off on crazy tangents. I love it. All right. So basically, my current role does still have me work on solving a lot of these problems from an organizational perspective again. And so at Hippo, we've got like 400 repositories or something like that. Like, it's just an ungodly amount of repositories. And we have, however, software that all build similarly, right? And on top of it all has like similar tool, or all has similar like build steps even, and processes and all of that. And so whenever we need to change something in those build configurations, right, by default, we would have to manually go in one by one, copy paste, right? And that's the problem that we're trying to essentially fix here is that we maintain a large amount of repositories which contain similar build configurations that require us to manually update each individually when changes occur, right? And again, across like 200, 300 repos, that's just, it's a lot of time, right? And so what we did is we started talking about, well, what do we have, right? Like, what do we already have? And we broke down what we'll call essentially repository types, right? And these types of repositories do or build a specific maybe piece of software or softwares, whatever, right? We have our Docker repositories, which are all focused on, building Docker images and maybe as like base images and stuff like that. We have Pulumi, which focuses on all of our Pulumi automation. We have Quirk repositories, which is for all of the Quirk platform. We've got our recording pipeline repositories, which is, everything for the recording pipeline platform, and so forth and so on. And you can even tell what's interesting is once we started breaking these down, we said like, well, you know what? We have some of these concepts in two places. For example, we have Pulumi repositories that exist on a lower global scale, right, within the organization. And then we also have localized Pulumi repositories for specific projects, right? Where we say like, okay, well, this manages everything in Alta for LLC, but this manages just Quirk specific things, right? And things like that. So we have that operation or that separation, right? But they still build the exact same way. So what we're already seeing is that if we build this tool, especially the way that we want, we know that if we build the Pulumi templates out and get all of that working, we can solve for it here, as well as here, as well as here, right? So that means going forward, even just by writing this documentation and sitting down and breaking out like what exactly we have, we can already see the value that we could get out of this basically just through seeing how we can, again, we can automate the Pulumi repositories in 3 different places, right? And again, that's 3 different projects. These aren't just one repository. There's multiple repositories here. There's multiple repositories here. Actually, I think there's just one repository here, but you get the idea. Do you aim to replace those files at work time or just update periodically? So that is something we're currently working on at Hippo. That's a very good question. At Hippo, I added a feature to our build tool, which is called a remote feature. And the idea behind it is that it can essentially actually use your SSH keys to go out, clone a repository, generate the changes, commit them, and then push them back up, right? Now, if you have that for one repository, you can obviously easily automate that for hundreds of repositories if you wanted to. And so at Hippo, we manually run that tool right now where I run it across all of our repositories and I just do it locally. So it's just like a really big cron job essentially that is manually run on, any of the developers' machines who want to do it. We want it to be automated. Like realistically, what we would like to be able to do is make a change in build configs, for example, like make a change in our build configuration templates and then just be like, okay, it'll go out, we can expect, unless it's something that has to go out right away, you know what I mean? You can just expect it to go out maybe on Friday, right? Or something like that. So like that desire of that periodical update versus like, just updating it when you can, right? Yeah, for sure. Like it would definitely be a goal. Right now, we're not really worried about it though, too much. There's a lot of other things that come into that play with that too, grapefruit, of like drift, and like not wanting to break pipeline. Like if you think about this is essentially a centralized, build tool system, right? And so the idea behind it is that if you change it in the central place and then that goes out everywhere, you could break every repository possible, right? So that's another kind of reason why we don't just like automatically push configurations. We're a little bit more sensitive to it, at least right now at Hippo. In the future, though, like I said, that might be something that changes, and it is something we would like to change. We'd rather it be periodical, where, again, I make some changes to something, it then, we can just say like, okay, cool, we know that it'll go out within a few days. Yeah, exactly, grapefruit. We've talked about doing something like that as well. Wouldn't that be solved by parsing all the repositories made by Pulumi GitHub to filter out repo types and generate the configs based on that? So you could, yeah. I mean, like if you wanted to do like so there's two parts to that puzzle, right? What we're kind of doing now is we're kind of jumping ahead of ourselves, and we're talking about a second part of the puzzle, right? The first part of the puzzle is just the CLI tool that I can go into an individual repository, run the command, and then get the templated files that I want, right? Like get these generated files out of it. That's one part of it, right? Then the second part is saying like, okay, how do we automate that across hundreds of repositories, right? Well, we've got the base functionality of saying like, okay, we can run the changes. Now what we need to do is we need to say, okay, how do we run it in an isolated place where it can clone, generate, commit, and push, right? And then how can it do that across hundreds of repositories? And once you get to that hundreds of repositories, that's where Pulumi GitHub, right, could come into play, where Pulumi GitHub could become parsable, and we could say like, okay, well, if we've got these repositories in Pulumi GitHub, then bim bam boom, we can then clone those repositories essentially. But again, there's like multiple parts to it. Yeah. Steffi, hey, how's it going? Thank you for the 22 months. Thank you so much. My company just banned Pulumi as we use Terraform. Not sure how I feel as I don't know any of those. Well, so Neochromer, I'm going to be fair. You could do the exact same thing with, like, what we're building has nothing to do with Pulumi or Terraform. What we're building is the build configuration CLI that will generate the build stuff that we need for that specific type of automation. But at the end of the day, like we could have Terraform repositories as well, and it would still generate the specific stuff it needs for CI CD. Like really what we're building here is this problem really solves for CI CD, right? This is really what this solves for. Anything related to CI or CD, these are these types of tools, right? Yeah. Okay. So like I said, if we look at a Pulumi project, for example, we have a Circle CI config that each one of these repositories has that are basically identical outside of a few variables. We have a git ignore, which is pretty much identical across the board, right? We have a Docker file, which is pretty much identical. And then we have a just file, which is also pretty much identical, right? If there's anything else that we would need, we can add it to the list. However, I don't think so. Because like I said, package.json, tsconfig, like all of these things we don't want to add right now. And you might say, why, BG? Why is that the case? Well, because we need to add one more thing here, which is we technically have this in two different languages. We have one in Go, and then we have one in TypeScript, right? And they both have the same files. However, let's go to the Go one really quickly. So let's see if the Go one has the same files as well. So Pulumi, I think it's Kubernetes. I think our Kubernetes automation is in Go. Yeah, it is. Okay, cool. Okay, so let's go back here. So let's see this. So just file. There's not a just file here, but there should be one, right? This is a repository that hasn't been updated yet. So this matches. Docker file. Okay, cool. That's there. Git ignore, that's there. And then Circle CI config. Now let's look at the Circle CI config really quickly. Now this is all old as well, but it looks pretty much identical. So the Circle CI configuration could be the same as well. So what that means now is now we could say like, all right, well, we've got languages, right? Languages of Go and TypeScript. And then we could say templates is these files right here, are template files, right? These are the template files that we've got. Cool. Now we've got a bit of a structure that we can reuse for the rest of the other ones, right? Or at least some of these other ones. Now I said we wanted to start with Pulumi repositories, right? However, we do have the option of being able to do other ones as well. I don't know. Maybe we shouldn't worry about that right now. Ever thought about supporting Bitbucket? For what? What do you mean supporting Bitbucket? I've used Bitbucket before. It's not my favorite, to be honest with you. It's a weird story. They just don't like it. Are they YAML ops dudes? That's funny. I'm just trying to think if I want to jump into the quirk stuff right now. Bitbucket's pipelines is what I meant. No, I literally don't use anything Atlassian related. Because I think Bitbucket's Atlassian, right? Isn't it? I'm sorry, for source code and stuff like that. Yeah. I just use Jira at work and Confluence. Yeah. Like I said, I've used Bitbucket in the past, but I'm just not that big of a fan. Yeah, this is fine. There's a couple other projects that I would like to jump into, but honestly, I can't work on them on stream. So I think for now, we'll just focus on Pulumi. Okay, cool. So this is what we're going to focus on for now. We're going to focus on our CLI tool being able to solve for the Pulumi repository type, right? Now, what's nice about this is it does allow us to keep... this very simple because although it's Go and TypeScript, the template files are pretty much identical, right? We're always going, oh, you know what though? That's not entirely true. The Docker files would be different. Yeah, because this would use Golang. So we do have a variant here actually, now that I think about it, which is if we look, right, our Circle CI will be the same, right? So this will be for both, right? The git ignore would be for both. The Docker file, however, would be configured, right? And so would the just file. And so actually what we could say here is right, or we could say is per language, right? Docker file per language, and just file would actually be for both, yeah. So realistically, what we're gonna need to do is we're not going to just be able to generate a Circle CI config for both, a git ignore for both, and a just file for both. But when we get to the Docker file, because the Docker file has different base image, like this is Go, it actually just has like a bunch of different steps in general. It makes more sense to have a Docker file per language, right? And so what we now kind of want to talk about a bit further is that DSL or that configuration that we spoke of before, right? So this is Nix, but we want to go to JSON. So let's go to JSON. So let's talk about that. What is that going to look like, right? Like, what is that going to look like? Well, first and foremost, we need to give it a name, right? And so we need to make sure that the repository configuration actually knows how or what the name of the repository is. Now, you might say, BG, why don't you infer this somehow? Why don't you like look at the repository? Why don't you look at the repository itself and just infer it that way. Sometimes the repository name is not the same as the application name. And that's something very, very clear. This is the actual name of the application itself. And what we could say is we could say like app name or, something like that. But for now, I'm just going to use name because I know what this is, right? So the name of this build configuration essentially would be Pulumi. We'll use Pulumi GitHub to start, right? We'll start with Pulumi GitHub. So let's go back to Pulumi GitHub. Let's pull this open here so we can take a look at it, right? And now we're going to say type, right? And so that is going to be a Pulumi repository, right? Because this is for our Pulumi automate. We could also just say Pulumi automation if we wanted to be a bit more clear. because then in the future we could also say Terraform automation. We could also say, whatever, right? So, or we could just say Pulumi and then Terraform, right? For now, I'll just keep it simple and we'll say the type is Pulumi, right? It's a Pulumi GitHub is the repository name. Type of it is Pulumi. Now, there's one other thing that we've decided that we know we're going to need to add. What do you think this third one should be, right? We know that we've got name and we know we've got type. What do you guys think this third one, at the bare minimum, this third configuration value and name should be? What do you guys think it should be? Won't get ignored, be different for TSN Go. So yeah, it could be. You could also just make a generate, or you could also just make a get ignore that manages both. You know what I mean? You could have one that has both go ignore. Like that's kind of what I was thinking more is like just have a big get ignore that ignores everything across all repositories. However, maybe, yeah. Yo, how's it going? How's it going, buddy? Thank you for the 37 months, dude. Yes, I do know who this is. You need to get your name changed on Twitch so that I actually can just call you by what I normally call you. Thank you for the 37 months, dude. Language component. So some kind of UUID. So actually, I have 2 Twitch users. I got to do a name swap. You do got to do a name swap. Thank you for the 37 months, though, man. I appreciate that. So the answer here is actually language. And the reason why is because we said that our Docker file needs to be per language, right? And so when we think about what are the values that we want to care about from a configuration perspective, well, we need to know the name of the repository, right? Or the name of the service. And we could even say, see, the reason why I don't want to call it service is because it's not technically a service here, right? And we could even call it a build name, maybe like a build name. But again, this is a build configuration, so that's why I'm just saying name, right? Because then it would be build.name, right? So yeah, when we talk about if we need, what are the basics we need for our configuration, that first one's definitely going to be name, right? The second one is definitely going to be type because these are the types, right? And in this case, we've got Pulumi as our type, right? BG, if you click, you can give him a nickname. I can give you a nickname? Seriously? I can block him. I can report him. Should I just report him? Mod. How are you not mod? There. You're modded now. You've been given more power. How do I give you an alias? I don't know what you're talking about. Oh. Felix. Haha. Bam. All right, now I know who it is. Oh my God. I could do that with chat? Oh my God, there's so many people I'm just going to rename to so I know who you are and you'll never even... All right. I did not. Yeah, I didn't know that was a thing, bro. Holy crap. Yo, what's up? Oh, Thug Muffin. How's it going, buddy? Hello. Okay, it's by the way, hello. How are you, buddy? See kids, this is what happens when you take part in a conversation you weren't here for the start of. Listen, you participated and you still get a reward, okay? Team participation is rewarded here too, okay, so you're fine. Had an interview for that job an hour ago, went really well, killed it, feel good about it. Hell yeah, buddy. I'm like I said, dude, I'm gonna be real with you here. I mean, I always am, but I'm gonna be real with you, right? When you and I talked about what you were going through back, a couple months ago, I always had the confidence that you were going to be able to have that opportunity ahead of you. And I think that's something that's very difficult for us to see. Like, I know I have opportunity out there. I'm very aware of it. You know what I mean? I don't mean to say it in like a rude way, but I just mean to say all of us do. Right. And so, yeah, like I'm glad that you tried it because you know what? You gave it a shot. You gave it your best and it didn't work out, unfortunately. So now you can move on with the complete knowledge that you get, you gave it your best. And that's good. You know what I mean? People like that as well. When you're interviewing, you can easily say, well, why are you leaving? Well, I gave the company the best I could, man. And unfortunately, they didn't deliver. Like it's very real. It's very common and it's very okay. So hell yeah, buddy. Wait, so only BG can see the nickname? Yeah, only I can see it. Here, look, see? Come here. Look, see? Felix. Shabam. Because that's his name in our Discord, Felix. He's also a mod in our Discord. If you guys don't know Felix, by the way, Felix Hammer Knife. Oh, there you go. All right, well, never mind. He fixed it himself. Did you literally just name change it? That's hilarious. Well, yeah, I appreciate that. Felix is awesome. Yeah, Felix is the homie. So many people. Felix, you just blew so many people's minds. Everybody's like, wait a minute. I know Felix. More like Felix these nuts. Yeah, you got him. That's like one of like the awkward meme got him. Like, yeah, gotcha. Yeah, gotcha there. Oh, the Go guy in programming. Yeah. Dude, yeah, you just blew so many people's minds. Felix is sensible, and he goes, you can't just say Nix is a solution for everyone's problem. Our poor mods, for every mod that has had to deal with our not deal with, but you know, get used to our new Nix community. Man, the Nix community is weird. I love it. I was a sheltered, like, introverted nerd for pretty much most of my youth. So like for me, I get it. I get eclectic, we'll say, different, you know. I don't know, but yeah, I feel like honestly, if you're into even like programming, that's like I feel like if you're a functional programmer, you just think differently. I really do. I haven't given it a try. Well, you will. Don't worry. I pray for patience with them. Somni, you are a saint, my friend. Seriously. And you and Felix both, like, listen, we don't tell you how much we appreciate you enough. Seriously. You guys keep our Discord alive, as well as all of our mods. Like, thank you. Seriously, thank you. All right, so let's jump back into this. Okay? I do mainly Go Python during the day. I got pulled into F# application once, and my brain pretty much melted. And my brain exploded. Yeah, that's how I fell learning Haskell. I'm learning Haskell on the back end right now. I wanted to do it on stream, but honestly, like, I'm not there. Like, I like to educate you guys, and like even with Rust, it's going to be a little bit difficult. So I'm going to be using ChatGPT a lot to help me today. Okay, cool. So yeah, so language is in fact going to be the third thing. And we're going to focus on TypeScript first. Now, because we have language, right? Because we have language, we can now actually say, all right, well, you know what? Let's add some support for some language stuff, right? So what does that mean? Well, that means that tsconfig could also be added per TypeScript, right? And if we wanted to, we could say this now is a TypeScript specific, a TypeScript specific file, right? Per language. And we could say, let's do this. We'll say both, or we'll say global. So this is supported for every language, right? Bam. So global circle CI, global git. So actually, you know what? Let's do this. I think you're right. We'll make a git ignore now for Go, right? And then we'll make a git ignore. We'll do that. Might as well, right? And then we'll make a git ignore for TypeScript, right? Circle CI should be the same. Docker file, right? Docker file needs to be. Now we're really getting to see what's different, right? Between these repositories, chat. Like, now we're really getting to see this, which I like a lot. The circle CI config in the just file, however, tsconfig.json. Thank you. Sorry. Thank you. Appreciate that. Right. Bam, there we go. These two really should be global, or all languages, right? So all languages should have the same circle CI config. All languages should have the same just file, essentially. Go, however, should have different git ignores, right? Same thing for Docker files. TypeScript, different git ignores, different Docker files, and tsconfig, which won't even be there. What else? Anything else that we can see here? Oh, you know what, chat? Pulumi.yaml. Yeah. Pulumi.yaml, right? So that's going to be a big one. And that should actually be something that's in every repository, right? So what this is going to be is this is the actual Pulumi configuration. And you might be like, BG, why do that one? Because if we standardize it, then we can standardize what our Pulumi automation is in Pulumi. So if we go to pulumi.com, right? One of the things that I kind of don't really one of the things I kind of don't really like about our Pulumi setup currently is that I kind of jumped around naming conventions for a bit before I found like what I liked. Hang on. Jiminy Crickets, man. Come on, Dark Reader. Kick in. There we go. And so like if we go to our stacks, you'll see like some of this was named like right where it's like Pulumi bucket, Pulumi container registry, but then this one's just like DNS. And then this one's like Pulumi GitHub, and then this one's just like machine user, right? So I kind of dropped the ball on some of this where we don't have a standardization across all of these. What this does mean is this may mean actually that we might need to recreate some of these stacks, which is going to suck if that's the case. We'll see. But yeah, basically that's another reason why it would be good for us to automate this, because then it's going to be the same. You know, again, it's going to be that consistent naming everywhere, right? Oh, come on, stop it. Stop it. Stop it. Oh my God. Dude, why do you just want to hover? Look, it's like, it's wanting to hover over, like, okay. Why not a kitchen sink git ignore or a generate one on the fly? So Darth Cajun, that was something I was talking about before. Right? I was just like, well, we could just generate a massive git ignore for everything and just call it a day. So there's a reason for this as well, and we can kind of get into this a little bit now, I guess, which is if I wanted to, now that it's a templatable file, I can give build configuration data to it. So if I wanted to, I could say like git ignore, right? And then I could be like, and technically you could do this for both, right? Git ignore, and then I could be like, you know, I don't know, .docker file. I mean, that's not something I would, wait, let's do, temp.json. I don't know. Right. And then what I can do now is I could take this value and I can inject it here. Right. But because we have the language as well, we can generate the specific git ignore for that language and then make it so that it's a little bit cleaner, right? And a little bit more valuable. I think if it was just like an overall bucket like git ignore, you just would never think about it, which is not terrible, but I don't know. It's something I guess what I mean to say is it's something I'd need to explore more. It's not a bad idea. But yeah, I was about to say it might ignore too much as well, which is something I'd be a little worried about is maybe, like, for example, maybe it ignores something in Go that you don't want it to ignore in TypeScript, right? Yeah, stuff like that. So that's why I'd have to think. What about a Docker file, a .docker file? Yeah, we could. I mean, that's not a bad idea, honestly. Dude, honestly, it's not a bad idea for Hippo either. I just realized that I was like, shoot, man, we don't even have one of those in Hippo. The thing, though, with the .docker file is what would we ignore? So a .docker file would probably be global just because, well, I don't know. Would we have, so with a with a .docker file, that's basically the same thing as a .git ignore, right? So in that case, we might be better off having a .docker file per language so that we have in the same way that we ignore, not globally. Because that's another thing, dude. I'm gonna be real with you. I hate it when something is in like a git ignore and then it's not in a .docker file, or vice versa. Or sorry, .docker ignore. Yeah, my bad. Yeah, Docker ignore. Yes, Docker ignore. My bad. Yes, Docker ignore is what we're talking about. Sorry, I'm tired. Yeah. And so like a Docker ignore, like, let's think about the value here, right? So if we Docker ignored the TypeScript, what would we Docker ignore? Well, we wouldn't want Circle CI, which is in both. That's fair. Resource we would want, right? Git ignore. So Docker ignore follows the git ignore too, though, right? I think so. Does Docker ignore follow git ignore. I believe it does. Yeah. Okay, it does. Yeah. So if that's the case, then what would be in our Docker ignore that would not be in our git ignore, right? And so if we did it at a global level, Docker ignore would have like .circle CI, right? The whole directory, right? What else? We need the Pulumi stuff. I guess README, right? Technically, we don't need the README in it. We need the just file. Package.json, we need to. So, like, yeah, if we did a Docker ignore, it would. I think it would just be global. Because I don't think there's anything really, at least from a, you know what I mean? Global perspective that we would have to really worry about. Whereas like git ignore, that is a little bit more like, you know, for Go, it would be like, I don't know. Well, for TypeScript, it would be like, you know, node modules, etc. Right? I don't know exactly what. I think this would probably be like build artifacts, right? Would be one. So that'd be like the name of, and like here's a good example and reason why we would have a git ignore for Go versus TypeScript is like the build artifacts is literally the build name, right? So what we can do is we can immediately add to the git ignore in Go the name of the build so that the build artifact itself never gets committed to the source code, which I've seen people do before. I've seen people build the binary in the same repository and then commit it without even realizing it. And like that's something we could guarantee essentially to never be a problem by just making sure that the build artifact or the build name essentially is also in the git ignore. So like that could be valuable as well as just everything else that Go needs. But yeah, I honestly don't think there would be much on a Docker ignore level that we would really care about that would be individual per repository, right? And then we could do etc here as well. Okay. So is there anything else here that we see that we might need to be concerned about? I don't think so. Cool. So do we think that this configuration is enough for us to be able to start? I think so. I really think so. I don't think, at least yet, we're going to need to add much. Now, I do know that there's definitely things that we can add, and don't worry, we definitely will when we get there. But I think for now, this is the basic configuration we really need to kind of focus around, right? The name of the repository or the build that we're trying to build, Pulumi GitHub in this case, right? The language, TypeScript, which will immediately select all of these templates, as well as, as well as these templates, right? So it'll select these templates. Oh, come on now. It'll select these templates, and then it'll also select these templates here. Oh, I guess I can't shift select, whatever. But yeah, TypeScript as well as the all, right? And then the type, Pulumi, will make sure that we then get this specific type for it. Cool. Okay, chat. Now the fun part, which is we're going to jump into programming now. Actually, is there anything else that we can think of? Repository configuration. We need a way to provide developers. Oh, let's say distributable CLI. Okay, so actually before I take a super quick break, let's talk a little bit about why we're using Rust, okay? So we need a way to provide developers with a simple CLI tool that can be run anywhere with minimal setup effort, right? And this is crucial, chat. This is crucial to this whole process, right? We know that we have our problem. We know what we already have, right? And we also know how we kind of want to configure our repositories. What we now need to understand is really more about the build tool itself and what its goals are at a higher level, right? And a big part of this is that it needs to be a distributable CLI tool, right? But I need my UI for ClickOps. No. Now, the goal here is to really be able, as a developer, to go into stream tags Python video show semicolons me. Oh, geez, do I have Python on my tags? I'm sorry. It's all of the languages I use, so I'm just not using Python today. Sorry about that, Mark. How's it going, though, buddy? So we need a way to provide developers with a simple CLI tool. Now, actually, what's funny, Mark, ironically, my dude, is that the tool we're building today in Rust, I have already built in Python at my job. So we are actually taking something that is originally built in Python and rebuilding it for Rust. So I don't know. That's some kind of consolation, right? How's it going though? Now, actually, and this actually, you bring up another good point that I can talk about, or I was about to talk about, which is the redistributable, or we could say, actually, instead of distributable, we'll say redistributable CLI tool, right? Python is a great language. It's a very, very fast, easy to use language that you can get a lot of really cool stuff done very quickly. And it's one of the reasons why we use it at Hippo, is because we can get stuff done really quickly with it. The downside to Python is really the downside to a lot of what are more called scripting based languages, which is it has packages that it has to maintain and be shipped with, right? Because it's not compiled. It's in what we call interpreted. Right. And the idea is that when you interpret something, you basically have a virtual machine or something that's going to then take that code and run it in a environment of its own. That's why we have like Node.js, for example. That's why we have what's it called? I mean, that's basically why we have Node. That's basically why we have browser support for JavaScript, and JavaScript runs, in the browser with V8. That's why we also have, Python and how it runs and builds stuff too, right? That is an interpreted language. Interpreted languages make it so that the twos are separated. You basically just have all of your source code at once and it reads it. So like that's literally how, if you didn't know, Chad, that's how an interpreted language works. That's why all of your source code has to be in the same place. It all has to be able to link and communicate with each other, because when the virtual machine or the tool, whatever runs that code for you, it needs to be able to have access to everything. And then at runtime is when it interprets and runs the program. With a compiled tool, that is completely different. With a compiled tool, it is, all of the source code as well as all of the modules are, combined. There's tree shaking involved and a bunch of other stuff. And the main point here with that is that then builds down to a single binary that then you can redistribute anywhere, right? And one of the challenges that we have right now at Hippo, and a big reason why we're building this tool, is that not a lot of our developers like to use it because it's in Python. Unfortunately, the tool required, or at least our tool required a decent amount of like modules and things like that to achieve what we wanted to. And so because of that, right now, if you want to use our build tool at Hippo, you have to clone the repository, you have to set up a Python environment, you have to pip install all of the packages, you have to make, there's a bunch of steps that you have to do. You have to make sure that you can authenticate with our private, JFrog repository. There's just a bunch of different stuff. And so, after like 6 or 7 steps, the developer's like, dude, I just want to generate my new changes. You know what I mean? And it becomes cumbersome for the developer to want to maintain and update their repository, which is what this tool is really for. At a larger scale, and this is why I'm saying that this is a DevOps focused project, we give this tool to the developers, right? So if you're in DevOps right now and you have to go into any repository and you have to, manage some configuration, configuration files or anything like that for that repository, this solves that problem for you. Where now what you are is the CLI tool, and you just tell the developer, oh, you want the latest changes for your repository? Just go download the CLI tool. You're done, right? And so in that case, then the developer gets the CLI tool. They run it really quickly. All their templates are updated. Didn't have to bother me at all, right? There's a separation there. And that's the other power to this that you're not really going to get to see with me, because I'm one person, right? But that is a real, like, that is one of the biggest reasons to build this. Is if you are in DevOps or you have a company that does use DevOps, right, as a practice, this is a way that you can save yourself a lot of time by saying, like, okay, this CLI tool that generates all these templates and does all these things for us, right? It essentially will make sure that if you run it, it'll give you what you need. That's it, plain and simple. And that's what we maintain, right? We don't maintain the source code of the templates as much as we maintain the tool with the templates inside of it. Are you sure you want to decide the templates based on language? You might have other templates of front end versus TypeScript. So you're actually you're not wrong. However, Whisper, we've got both of those here, right? So remember, right now we're only focused on Pulumi, but if we do try and add on to this a bit, this could also be a Quirk front end, right? That's built in TypeScript, right? Like, language and type are going to have to work side and side here, because as you might know, right, you can also have front ends in maybe WASM, right? Maybe we do like Rust WASM, right? That's a front end, or maybe we say that we have a Quirk back end, right? That's in TypeScript, right? Or maybe we decide to make one in Go. So that's why language is going to be here at the very beginning, right? Because language and type literally work hand in hand. Yeah. Oh, my bad. Was referring to the Hippo situation with the Python CLI config manager. Don't you, sorry, what? Oh, my bad. But yeah, sorry, great. I mixed up Grapefruit and Whisper there. But yeah, I think that language and type are going to, work hand in hand here. I think the only thing that makes it look like it's not is that because I did Pulumi, and then I did languages inside of it, but technically language and type are on the same level. You know what I mean? In this regard, it's just we're seeing it from here because we broke down just what Pulumi looks like. But realistically, Docker probably wouldn't have any languages, right? It would just build a Docker file, right? Whereas Quirk, this is where, Quirk, backend, bot, all of these would have languages, right? Everything else basically would have a language except for probably just Docker file, right? Because Docker file is just focused about building base images. Is there also anything that affects coding when upgrading to Windows 11 from Windows 10? But I don't, I had a friend of mine who posted something on Facebook about this the other day where he was like, I'm thinking about upgrading to 11, any thoughts, recommendations? And I was like, honestly, dude, I've heard that there's problems with it and stuff. I think I said, I've heard if you want support for anything, it basically sucks. However, he installed it and he said he's been having a good experience. And I said, awesome. I just responded to him. I was like, hell yeah, that's cool. So, I could be wrong. I don't know how well it would work for development, more than just gaming. I really don't know. So, give it a shot if you want to. All right, Felix, we'll see you in a second, buddy. I feel like Python tools always were the most troublesome for me. Yeah, I mean, again, I love Python. I really do. I think it's a very powerful language. The only problem with it for me, honestly, is just it's the same problem I have with TypeScript or JavaScript. It's just when we talk about redistributability. I don't know. I don't even think that's a word. The ability to redistribute it. It is. Yeah, it's definitely more challenging. That's when you have to rely on Docker files and stuff like that. And I think even somebody said couldn't you just build it in a Docker image? I could, Whisper. I definitely could. But once you start working with Docker, then you have to figure out okay, well, what user is it committing the code for? Think about that. Think about having to run, commit changes and stuff like that inside of a Docker image, because at that point, that's what you have to do when you run it as Docker, or potentially you might have to do. So it's just, I would much rather just keep Docker out of this or anything out of this and just focus on making sure that we can redistribute this as easily as possible, right? And so there's a couple ones that are on the list right now for me, and that's really going to be between Go and Rust. Binaries for the win. Yeah, binaries for the win for sure. Now there is another one that I also thought about doing, which was Haskell, but we're not going to do that because I'm learning Haskell on my own. So let's talk a little bit about Go and what, the values are. So Go obviously builds to binary, right? That's fantastic. Easy to work with, right? And we can call it, we could say that it's fast and efficient, right? Efficient, or it should be, if I could spell the word efficient right. Fast and efficient, right? The downside to it, though, and this is a big downside, is the template, or it has built-in templating, right? Now, here's the thing. The built-in templating is more general focused, general use focused, right? And from my understanding, has limitations at higher levels, right? And so what I mean by that is like, we need to think about a couple of things. What it's going to be built to. It's going to be built to a binary. Cool. Is it easy to work with in the sense that can we like build project or build with other, open source code and stuff like that? Yep. Is it fast and is it efficient? Yep. Like these three are basically the same for both Rust and Go, right? Builds to a binary. I don't know if I would say easy to work with, but easy to maintain, I would say easy to maintain, and it's fast and efficient, right? The difference is here is that with Go, the built-in templating is general use focused and has limitations at high levels. Now, when I say that, to give an example, right? With Go, you do something like this. You say like my value, right? And then this is your value that is eventually used. And I do know that there's like other things that you can do with Go. Like for example, let's see here. Golang template functions. Is there such thing as like template functions? I don't even know if there is. Because if there is, then I don't know, maybe Go would be the easier approach here. Yeah, so this is kind of a bit more of like what I'm talking about here, which is like from a high level, right? You can do a lot of simple things with Go templates, right? You can do like if and stuff like that, right? But one of the things that, in my opinion, is very, very powerful with other things like, say, for example, Jinja and stuff like that, is being able to like pipe and have like helper functions that you can easily create and stuff like that. Let's see, user has permission. Function string bool. So yeah, like this is where things get very interesting. Like this is what I mean by the templating. Okay, just look at this. So in this example, right, they have a type struct that on this type, it gives a has permission function with a response of a Boolean, right? Essentially, Go has the limitation of, with its templating, where you have to pass the view data down entirely before being able to use that data, right? And so if you notice, to be able to pass a function to a template, right, you actually have to provide it as a piece of data in the view, like you see here, right? And then actually say call user has permission, and then like so you really have to like recreate the whole function here just to get it to work the way that you want. And it's things like this that make me not want to use Go templating. Because I would, instead of saying like, okay, call value, or we'll say like call.value.myFunction, right? And then like parameter, right? In a Jinja world, it would just be like, you know, value, and then I could say like my function, right? Like this is in my mind way nicer than this. And what I'm trying to tell you, chat, is that if I use the Go templating, I'm constricted to do all of my logic this way, right? And like, here's another thing. I can't even, maybe I want to do my other function, right? Like I can't even do things like this as well because of simply the limitations with how templating works with Go. So that's a big reason as to, we'll say, open source templating, right? And the reason why I would much rather use an open source templating is preferably, oh my God, I can't spell, preferably use Jinja variant, right? And a big reason for that is so that we can be able to rely on things that we're already used to with Jinja, like, you know, piping, being able to have functions that we could just easily use within our templates, and really having more of like a holistically like problem solver for templating, right? Looks like PowerShell piping to me. When you're templating stuff, this isn't a bad thing, right? Because then I could say like my function true, and then be like, you know, my other function 45, right? And then what it'll do is it'll take the value, it'll pipe it through the first function, right? It'll return this, and it'll pipe it through the next function. And, you know, think about this. Think if I wanted to be able to have two calls next to each other, right? What I would need to do in Go, like say if I wanted to do something like this, greater than 0, right? Or if, so here, I think this is more of what it would look like. If value greater than 0, right? So this would be what it would look like in Jinja, right? And if something like that. I think I need like these guys too, technically. Yeah. So this is what it would look like in Jinja, right? Versus this is what it would look like in Go. I'd have to do like this. Actually, I don't even know. I don't think you can pipe. So I don't even know how you would like take one value and then like get that value and then move it forward. You talking about this? This, you mean, which gives you Helm vibes? This one or this one? Actually, both kind of should, because they both do very similar things. But yeah, I to be honest with you, I don't even know exactly. I guess you would have to like evaluate it. Yeah, like, see, like, how would you do that with Go? I don't even know how you would do that. Can you do... I genuinely don't even know how you would pipe. Like, I don't know how you would pipe in a Go template. Again, I don't even know if you could. Like, I guess... Oh, I think what you'd have to do... Well, that's just Jinja, foul. That's just Jinja. Like, this is Jinja. This is everywhere. This part, though, this is more like Go specific. So I think what you would have to do, honestly, chat, is you'd probably have to do something like this. Oh, wow, that's confusing. Yeah, you'd have to do something like this, right? You'd have to look at it from a functional perspective, and you'd have to say, like, okay, call my main function, which then calls as a parameter, and then evaluate this, which will then, you see what I'm saying? So, you know, again, like, I don't know, to each his own. I personally would much rather have this for now, and that's another reason why I would much rather use a Jinja variant with Rust than utilize the built-in Go templating. And another big thing, and this is really another reason of why we're trying to use Rust too, is just it's something I've been wanting to try for a while now and see how I would like maintaining a project in Rust. So again, between Go and Rust, they're almost identical here with regards to like why we would choose one or the other. And there's a solid chance that, like, honestly, like Golang, Jinja 2, right? I would imagine there's some type of Jinja plugin, maybe. But it's still going to be, I don't know, it's still going to be all around the Go templating, I think. I don't even know what this is. Yeah, I don't even know what this is. So yeah, in Go, a lot of the templating seems to be mostly like, if you're going to template in Go, you might as well just use their built-in template. And we can say much more options available, right? And preferably to use a Jinja variant. So yeah, like I said, when we talk about a redistributable CLI, I do really think that, again, Go and Rust are really good options here. If you wanted to build this in Go, you definitely could. I definitely think you'd have to figure out the templating a bit more. Whereas like Rust and using something that is like more open source templating, where again, I could either choose to use, Jinja, I could use other templating and handlebars. Like that's another thing too, is like with, let's see here, Golang handlebars. Is handlebars even in, yeah, see, it doesn't really like, oh wait, hold on. Is this an actual? Yeah, see, like a lot of this stuff just doesn't really seem supported. Whereas if I do like Rust, yeah, there's a literal repository called handlebars, right? Which is honestly, we could just use handlebars. We could much rather, very easily use handlebars just as much as we would want to use Jinja. But that's kind of my point. Is like, if I can do, Jinja, right? Terra, template engine for Rust based on Jinja 2 Django, right? Like this just makes me more confident that we'll have a better time templating with more support of open source software or open source tools and stuff like this. Like the images of rusty handlebars. Yeah, exactly. So I leave it up to you, at least in the sense of which one you would pick for this. Hopefully it's maintained. Yeah, no, trust me. I super agree with you on that one, Foul. Don't worry. Yo, Scotty, by the way, dude, thank you for the 9 months, man. I really appreciate it. I'm doing Rust for DevOps things today, too. It's even more fun. You get to do the next Nix integration part. We haven't even talked about that, but I've already done it, Scotty. I've already integrated our Rust project with Nix, so we'll talk about that in a brief minute. So yeah, like I said, I leave it up to you. If you would rather do this in Go, I have no arguments there. Like honestly, like I said, the only real challenge I think is that you would deal with is the templating. I think you could build it the same. I think you could build it, as efficiently. I do think, like I said, the built-in templating is going to be a bit more of a challenge. Whereas like with Rust, you'll get a lot of the same things, and you'll get more of like an open source templating where, there's a lot of other options. You could say like, okay, I want to use handlebars. Okay, now I want to use Jinja, because Go, and I think this is just like the one thing I didn't really realize until I looked at it, which is I think because Go has built-in templating, nobody really cares to try and replace that, which is fine. That's totally fair, and I get it, right? But I am saying that like I was a little underwhelmed at how few options there was out there for Go when it came to templating, just because again it already had a built-in one. Pongo 2, what is Pongo 2? What's up, GD? How's it going, buddy? Pongo, what is it? Pongo 2, a Django like templating engine for, okay, so there you go. Yeah, like this would be closer. Yeah, like this is a good call. Pongo would definitely work here for sure. Now, again, I am doing this because I'm also going to try Rust for the first time, but yeah, this is perfect. Yeah, like see like macros and like, although, you know what? Look at this. Although this is actually, that's right. This is more Django style. This is a bit more Django style. But like, this is nice. You know what I mean? Like, look at that. Like, that's nice. I got a function. I want to render user details. Bam. You know what I mean? Like that's just super nice to me, I think. Yeah, I like that. Good call out, man. I appreciate that. All right, so like I said, we're going to do this in Rust, and we're going to focus on being able to basically have a redistributable CLI. Now, here's the thing, and I will say this too. If we get to a point where in Rust we're just like, oh, this is just not fun to maintain, who knows? We might switch over to Go. We really might. But I do want to at least start with Rust and see how far we get with it. Okay, cool. So really, outside of that, dude, I think we're pretty much ready to go. Like I said, we have our repository configuration that we want. We know the template files that we need and how we're going to kind of configure them. And now we also know the language that we want to build this in, right? So basically, we can just start programming. Before I do that, let me take a super quick break, if that's okay. I haven't gotten up for 2 hours. I'm going to get up really quick. I'm going to stretch my little dev legs and go to the bathroom. And then when I come back, we're going to go ahead and jump into it. Now, I have started the project a bit. I will say that. I have started the project a bit. And if you notice, I actually do have a little thing in here for a flake. And that is because I have integrated this into... oh, geez, Steffi. I'm going to be real with you. I don't know if I can. Okay, I guess I can. I was a little nervous about it raising. There we go. Cool. Okay. So yeah, so like I said, we're going to go ahead and jump into the programming part now because I feel like we have a really, really good understanding of what we're trying to build. Does anyone, before I take my super quick break, does anyone have any questions about what we're building today? Are we now all on the same page with what we're trying to achieve and how we're trying to achieve it and all of that stuff? Does anyone have any questions before I go to the bathroom here really quickly? Cool. All right. Well, if you do, leave them in chat, okay? Now, I'm going to take a super quick break. While I take my break, I'm going to run an ad, okay? The reason why I'm going to run ads during my break is because you don't miss anything when I run those ads. We do have to run ads. Twitch wants us to be doing this more often. And so when I'm gone, I basically take a quick little ad break. If you are new to our channel, be sure to check out that little blurb, really, by the way, as well as check out the Discord, the YouTubes, all of that good stuff, as well as the socials. Yo, Mindstormer, what is up, dude? Thank you so much for the raid. I appreciate you, my friend. Hello, hello. Mindstormer, give me a quick second if you don't mind. I'm going to run to the bathroom really quickly before I jump in here. But hello, Mindstormer. We made it right in right in time. Yeah, dude, you made it in perfect time. I'm going to run to the bathroom really, really quickly, okay? I'm going to run to the bathroom really quickly. Mindstormer, give me a second. If not, at least tell me how your stream was, dude, before you head off. Don't worry. I totally understand that, right after your stream, you want to chill out. So all good. But yeah, thank you so much for the raid. Yeah, raids when you want to go to the bathroom. Classic. Yeah, exactly. All right. Yeah. So give me a second. I'm going to take a super quick break. I'm going to run an ad during that break. When I get back, we're going to hop into Rust. And not only that, I'm going to show you how you can run a Nix or how you can run a Rust project with Nix. All right. So give me a second. I'll be right back. We're going to jump into it. Give me 1 second. We spent the whole stream. Oh, nice. Perfect. All right. Well, we're going to be doing more of that. Nilium, thank you for the 100 biddies. I appreciate that. Thank you, man. Thank you. All right. Give me 1 second. Be right back. All right, chat. I'm back. Oh, perfect timing. Okay. So I thought about it while I was gone. And there's one exception we're going to make to what we're about to build. All right. And that exception is I am not going to try and be perfect with this. Okay. I am not a Rust developer. Or I shouldn't say Rust developer, but I do not know Rust very well. And I'm going to try and learn the best I can, okay? I'm going to learn me some good, except for this time it's not Haskell, it's going to be Rust. So, with that being said, chat, there's a couple things that I wanted to do before I moved forward with this. One of the first things I wanted to do was I wanted to Nixify this project. Now, if you guys are curious about Nix and Rust, I'm about to literally show you how you can set up a Rust project with Nix, okay? Now, if you do not know what Nix is, and this is a video that I'm going to be putting out here within like a week, probably. Yeah, it's gonna be put out at the end of this month, basically. But I like to utilize something called Nix. Now, Nix essentially is three things. Okay, it is a language, it is a package manager, and it is also an operating system. Now, you looking at my screen, you're actually seeing all three of them. I use NeoFetch. I use Nix OS as my operating system. I use Nix package manager to manage and build a lot of my software. And I use the language to configure all of those things, right? And so the idea here is that we want to utilize Nix almost as like a Docker replacement. And there you go. There you can see my operating system here is actually NixOS 2305, right? And so the goal is to be able to build the package, to run the package, as well as to be able to have what's called a dev shell where everything that I need is inside of it, okay? Now, you might know that my dot files are also managed with Nix, and that's because they are. And if you've ever noticed my dot files before, you might notice that I have something called a flake.nix file. Now, there's actually a YouTube video out there that I made on the YouTubes. Here, let me find it for you. Where I show you guys how to develop using Nix flakes. I recommend watching this video. Oh my gosh, I can like plug my own YouTube content. This is amazing. I recommend you watching this video because that video gives you a jump into what a flake is, how it works, and like all of it's basically the whole reason why we use flakes. The TLDR is you can kind of consider a flake as like, it's kind of like your Docker file. You know, with a Docker file, you build your artifact and then you get, you know, your image out of that. With a flake, you build what are called derivations, and that's where your software exists, basically. And I do, again, I talk about all of this in that YouTube video. I recommend you go watch it. It is for Python, but it doesn't matter. Like the example is with Python. However, what I explain in the video is applicable to all sorts of languages, right? And you'll see a lot of the similar steps that I'm doing with Rust are basically going to be the same for, in a lot of ways for any other language. The only difference will be what actually builds the thing. And you'll see what I mean by that in a second. So again, this is my dot files configuration, right? So this is where I build like my NixOS configuration, my Darwin configuration for my laptops, right? All that kind of stuff. However, it's the same process or same concept essentially for building software. Now, to get started, there's a couple of different things you can do. You can do Nix flake init, right? And that will generate you a basic flake file. You can just create a flake.nix file right there and start working with that. Or you can try and find solutions on the internet and stuff like that. I've already got my flake file created, so I'm going to go ahead and just open it up. But the main point is to start using flakes, you have to create a flake file, right? A flake.nix file. So I've created my flake file. Let's take a look at what is inside of it. Now, as I talk about in the YouTube video I just linked, flakes are consisted really of two main things, inputs and outputs, right? And an input is essentially exactly as it sounds. It's a input that the build uses to build the software or anything that we need. It might be dependencies, it might be literal other pieces of software that run, like it could be literally anything, but these are the inputs. Now, this is kind of like having packages for your build, right? And you might be like, BG, what exactly does that mean? Well, if we try comparing this to a Docker file, for example, so let's go back to Pulumi GitHub as our example, right? And if we go to the Docker file in Pulumi GitHub, you're going to see that we have this right here at the very top, this from, right? This from is, yes, from is exactly that. From is essentially input in this regard. However, the difference between the two is that with from, you don't get any control over the version of package or the checksum. You have no way of validating that package because once you use the from, you use the package manager that comes with the operating system, right? Now, unless I change that, where then I come in here and I say like, okay, I want you to use pip, right? Or I want you to use something or something else. It will always naturally use the package manager of the operating system. This right here, this step is the first gigantic leap from being in an imperative build system to a declarative build system, okay? In this imperative approach, we just tell it where it's from, right? Whereas in this declarative approach, we don't just tell it where it's from, but we also say the exact inputs that it's going to use, right? And so essentially what is happening here is, because Nix is a package manager, it removes the need for the operating system's package manager and relies on its own to build all of its own packages. That's the real TLDR, because you can use this flake on any operating system. As long as you have Nix CLI installed and the package manager available to you, you can input these on any system, right? Whereas this says, okay, well, this is a node image and you can only run packages and install packages from this node image, right? So that is the first big difference between these two. So in a flake, I tell it, okay, well, I want flake utils, which is essentially a package. I want nersk, which is also a package. And then I want Nix packages, which is also a package. But remember, in the Nix ecosystem, Nix packages is the actual package collection of every package in Nix, right? So next to the two, or so basically side by side, not only do I have individual packages that I want, but I then also have a place where all of my existing packages are. So if you were to say, hey, BG, does that mean that if you remove this, you don't have access to any of the Nix packages anymore? Yes. Right? In this scenario with from, right, I always have the package manager that's shipped with this image. Whereas here, I can actually say, I don't want all packages. I don't need access to all packages. I only need these two, right? So that's kind of my big point here is in this scenario, we just tell it where we want to from, whereas here, we don't from anything. We tell it where all of our packages come from, essentially, right? And those become inputs. So it simplifies a lot and makes it much more declarative and saying, we don't care about what operating system you're on. We don't care about blah, blah, blah. We simply just care about where your packages come from. So those are inputs, right? Use Crane better than... So here's the thing, Scotty. I'm going to be real with you, dude. The only reason why I'm using this is because this was just the first thing that worked for me. As you might notice, my flake is not heavily reliant on it. So if you can give me a link that I can literally replace what is in my existing flake with that, I don't mind doing it. However, right now, I don't want to spend a bunch of time switching over to Crane. So... But Scotty, yeah, if you don't mind, like, send me a link or something, dude. Okay. Actually, here. Let's do this. Bam. All right, there we go. Because I'm technically using Nix here as well. Yeah, send me a link though, Scotty, so I can look at it. So as I said before, right, in a Docker file, we have a base image, we'll inherit the package manager from that system, and then at that point, like, we just install stuff, right? So again, think about here. Let's do this. Let's do a lucid chart. I think having a lucid chart here can really help exemplify, because I really want you guys to understand what I mean in the sense of just we're grabbing only the packages and we're not caring about the operating system at all. So let's do this. File. Just give me a second. Let me make this background a little darker so you guys aren't blinded. Let's make this dark mode as well. Let's refresh this. Yeah, Scotty, send me a link though, please, so that I can at least do it later if I need to. Okay. So, all right. Again, I'm going to try and just make this as simple as I can so that it makes the most sense, right? Let's grab a group really quickly. Load more. Just give me a generic group. Yeah, generic group. Perfect. Here's my generic group. Let's get a bit more color. Yeah, there we go. All right, so say this is my Docker file, right? My Docker file, if we say Docker file, let me give this the color. we go. White. There we go. Docker file. Within the Docker file, we have our from, right? And that from, oh, come on, man, is essentially like a big container, right? Itself. And inside of that big container is going to be all of the packages that you install from, right? Don't disregard the process thing, right? Here, let me get rid of that. So we've got like our main from, right? And then inside of this is like a package and then a package. However, with Nix, what we're doing essentially is we're saying, you know what? We just want to know where the packages come from. That's it. Right? There is no operating system in the Nix world, right? We just care about packages. So what we do is we find where those packages exist, and then we check their versions and all that stuff. Oh, no, you're fine. You're fine. Okay, cool. I appreciate that, Scotty. Right. So that, again, that's really the big difference here is that the from is what manages the packages, right? So from, in this case, if it was apt or appit, right? If it was apt, then these would be packages from apt repositories, right? If this was yum, right? Then it would be packages from yum repositories, right? It all depends on the from. However, because of that, there's a disconnection between the Docker file and the packages, right? There's a disconnection between them, and that disconnection is the Docker from, right? So that's what makes it so that the Docker file doesn't care about where your packages get installed from. Because at the end of the day, all it cares about is the commands it needs to run within the actual container or the actual build step, right? In a Nix world, however, right, we remove this image layer or this operating system dependency, and we say everything builds the same way, everything is accessed the same way. So what packages do you need, right? And so what that allows us to do is that allows us to tie the packages directly to the configuration, right? So before, these packages are not tied to the Docker file, right? But in a Nix world, they are. And that's the big difference is Nix knows where your packages are from, whereas a Docker file does not, right? A Docker file doesn't care about where your packages are from. Does that make sense? Does anyone have any questions on that? Because this is a fundamental concept that you need to understand if you're trying to work with Nix, which is because this is now, it's not agnostic to a specific operating system, or it's OS agnostic. Sorry, guess what I mean to say more. Yeah, that's what I mean to say. Because it's operating system agnostic, then what I can do is I can say like, all right, we'll tell you what, now I want to build on Linux, right? Or Mac OS, or even Windows, right? I can do that because Nix separates itself from the operating system, right? So again, the key factor to note here between these two is that essentially in a Docker file, the operating system exists, the declaration of the operating system exists inside of it, and the packages are linked to that definition, right? Or they could be, right? Whereas in a Nix scenario, the packages are linked directly to the configuration, and that configuration can be run on any operating system. Make sense? Does that make sense? Cool. And actually here, a better way of putting this is, we'll just do the same thing. We'll say, boop. And then this isn't Nix, this is from base image OS, right? And again, as we said, this links to this, right? And that's why the Docker file is what maintains the operating system, right? However, Linux, Mac OS, Windows installs Nix, and then Nix goes out, gets your packages, and builds them for you. So what does that also mean, chat? That means that Nix doesn't use containers. There's no type of container usage or anything like that with Nix. Can I like send it back? Yeah, there we go. And so that's another big difference between the two. These wrappers, especially on an abstract level, are incredibly important when we talk about what exactly we're trying to achieve, right? And again, as I said before, sorry, let me just make these look a little nicer. Because the packages are linked to the image, they're always going to be with that image, right? And that's why, again, whenever you update a Docker file, in this scenario, you have to update the packages inside of the image, right? That Docker file then can be ran on any operating system of your choice. But because they aren't containerized in any way, shape, or form, right? We don't have that containerization layer to worry about. The operating system, and actually here, if we want to go completely one full level, this is the full level in a Docker scenario. Bam. All right. So here's your operating system, your Docker file, your base image, and then your package. Whereas here, it's your operating system, Nix, and then your packages. The Nix configuration file is always present in the repo for this. Yes, it does. So it doesn't know where it's from. No, it does. So wait, what do you mean by that? You don't know where it's from, Gannett. What exactly do you mean by that? Cool. Okay. So I hope that helps you guys understand how packages work, at least with regards to a Nix file, right? With an input. So again, here's those inputs with those packages, right? And again, here's that from, and then we'll be installing the packages and things like that, like this, right? Thank you for the follow. The second thing we have is outputs, right? Now, this in a Docker world is really your build stages, right? And because we only have one build stage, we only really have one output in a Docker scenario, right? Whereas in a Nix scenario, just like you describe your inputs, you also describe your outputs, right? And so what that means is that I can tell it, hey, I want multiple packages I want to build, right? And this is how I build those packages. Now, I only want to focus on the packages side for right now because the other two are not really specific to what we're talking about it. Yeah, exactly. Less steps. Yeah. So this is what we're going to talk about first, which is packages, right? Don't worry about any of this other stuff up top. Just only focus on the packages part here. When we say packages, we mean the actual packages we build, right? Because as I told you with Nix focuses entirely on the package rather than images or anything else. And that's what you do in Nix. You basically package things. In our case, we only have one thing to package, which is our brand new Rust application, right? And if you look here, it's a very simple Rust application. We have a cargo toml. In my cargo toml, I have a name build configs. I have a very simple dependency of clap. And then if we go to source, right? I have a very simple source file here where I just set up clap and I handle one command, which is the generate command with an argument of config. So I've already set all this stuff up, right? So I have a very simple Rust application. And so if I wanted to, I want to be able to package that. I can do that with Nix using the packages configuration section. Now, this does get a little fancy. So again, remember this is in functional programming, so it does look a little different. But to explain essentially what this is doing, I can kind of reformat it a bit, and that might help too, to be honest. So here, let's do this. There. That should help a bit with the sense of just like what we're looking at here. So what we're doing is we're saying, hey, we have an inputs of flake utils of NERSC, and then I don't even know if I'm saying that right, by the way, and the Nix packages, right? And again, this can have one package in it. It can have tons of packages in it, right? It doesn't matter. And that's all because of this, right? So for example, if we wanted to use the flake that we have right here, right, we would say build config.url equals, nope, sorry, GitHub, oh, geez, I hit the wrong button. GitHub Alt F4, sorry, Alt F4 LLC, LOLC. Oh my, dude, that would have been awesome if we could have been an LOLC. Hell yeah. LLC / build config. And now I'm using it as a flake. So what does that mean, chat? That means that the packages that we declare here is now usable here. Okay? And so that's exactly what these packages do too. They have flake utils with its own set of packages exported. Nerisk has its own set of packages exported, and Nix packages has its own set of packages exported. And so that's what enables that other step of saying, okay, well, instead of saying from base image and then installing our packages, right, we actually have just one step, which is Nix, tell us where our packages come from. And so again, a repository can have one package in it. It can have tons of packages in it. It's really up to, the maintainer. So yeah, in this case, we have these three. And then you can see in our outputs, we're actually able to use those as parameters, right? And these are functional parameters. And this is an actual function that we're running to return our configuration, right? Okay, cool. So in our case, we've only got packages 1, and that's our default package. Now, default is actually used as like a little standardized helper. And so what that means is that I can just say the build configs package, and that's all I need to say. I don't need to say build configs. I don't need to say build configs.default. It'll basically know if there's a default to use the default for that specific package or for that specific operating system. And so that's the second thing I wanted to talk about, right? So we talked about the key and what it does. Remember, chat, if you guys are interested in what I explain here, I do talk about this in the YouTube, so please watch that video. So if a random dev would like to contribute to this project and he finds a flake.nix in the repo, he needs to have some component of Nix installed on his machine to start using the flake. Yes. So if you want to use it as a flake, you totally can. So here's a better example of that. You saw me earlier run neofetch, but if we go back to that command, Nix shell, Nix packages, now that you know what Nix packages is, you should understand what I'm doing here, which is I'm telling it where I want to get a specific package, and then I'm saying pound, or whatever that's called, hash, neofetch, right? And so what I'm doing is I'm actually telling the Nix shell to add neofetch to my shell so that I can run it. And so this is another powerful utility that I'll show you a little bit later, that you'll kind of see me use within Nix, which is Nix allows you to directly reference packages from the package manager and not only build them onto your local machine, but literally run them as well. So when I hit run like this, it goes out to Nix packages, finds neofetch as one of those packages, right? So as I said before, we go back here. That means that in Nix packages, there is a neofetch configuration, just like the default, right? And that neofetch configuration has all of the stuff it needs to build and run neofetch. And because it's default, right, then I just use neofetch itself, and then I can pass it the command that I want it to run in the new shell. And in that new shell, I tell it to run neofetch. And so that's how I can, within one command, go out, find a package, install it / build it, or build it / install it, and then run it within one shell, so that when I leave that shell and I do neofetch like this, I can't access it, right? And again, watch the video if you're more interested in how all of this works. That video, I do a pretty good job of explaining what a Nix flake is, and again, the packages and stuff. And I do also have a YouTube video coming out at the end of this month where I talk about what Nix is at, a higher level, kind of like how we're speaking as well. So yeah, subscribe to the YouTubes. Okay, cool. So as I said, we really, whoops. So wait, what happened? I closed the shell. That's right. So build config. Let's go back to our repository. Let's go back to our flake. Okay. So now that you have an understanding of what packages is, right, we can just talk really quickly about this section here, which is the actual function we're calling to build the specific application, right? So as I said, packages is just to tell Nix where all of our packages are defined. Default is the actual package we're going to build. You might notice that I have a function that I'm using here called for all systems that's wrapped around all of our packages. The reason why I do this is because this is a little trick that you can do within Nix Flakes that enables you to basically say, all right, well, here's the supported systems that I want to support, right? And so you'll notice that up here we have like, x86 64 Linux, we have 86 Darwin or 64 Darwin, we have Arch 64 Linux and Arch Arch 64 Darwin, right? So basically we're saying that we support Linux operating systems on x86 64 as well as on the new ARM or whatever processor that Darwin machines run, right? Or Apple's run essentially. So we only really support those two architectures or those architectures, right? We could support more if we wanted. We could simply add it to this list. But right now, these are the only 4 that we care about. So what that means is that I automatically, just by writing this simple function, can now build my package for any operating system. Because what I'm going to do is I'm going to use the value that comes from the for all systems returned function system to then pass that into my configuration as I go through. And so this is how I can make it so that it can run on any architecture that I decide. And those packages will then be targeted for that specific architecture. Now you'll see here that once I have for all systems and I say system and then I do default, right? Default is our default package, right? I then use another function inside of that to build our actual Rust application. So this is where we're building our Rust application. So everything outside of this, like everything up until here is Nix, right? Everything up in here is Nix specific. It could be done in using any language for like Node.js, Python, Rust, Go, all of that, like up to this line, I think, and I hope, again, for any Nix users out there who are proficient, I hope we can agree that this is all just Nix specific stuff, right? Like this is just Nix setup code, right? Once we get to here, and this is really all, this is your application build code, chat, right there. That is literally all the application build code is. Because this is where we're actually telling Nix what the application is and what we're trying to build. Now, as I told you guys, these are packages with their own software or with their own code in them that do their own types of things. So what we're really doing here, if we really break this down, is we're saying, hey, our Nix Flake has a set of packages in it. We're going to build for all of the systems that we support, and for each one of those systems, we're going to declare a default package with it, right? So on x86 64 Linux, there is a default package that we're building for, and that's going to use Nersk to then on that system, and this is how we achieve each system by using the system variable, use the build.package function. Right? Because remember, this is all functional programming. So we're just using tons of functions to do things that we want to achieve. And then we simply say source. That is literally it, chat. That is literally it. Now, I'm going to be fair. If I wanted to make this flake even simpler for now, I could delete all of this. And that is all I need to build a Rust application in Nix. Now, earlier, Scotty recommended something called Crane. This is another way of essentially using a predetermined package, Crane in this case, instead of Nersk, to build your application. And again, look at this, packages.default. So it's the same thing, right? Packages.default, my crate. We look at my crate. Where's our definition? Now, here it is, my crate. Crane build package, right? Let's go back to what we have now. Nersk build package, right? So this is the power of Nix, which is like you can, in a lot of ways, use the language and the utilities to just grab what you need. Like just be like, okay, I just need this and I'm just going to do this, right? And it makes for very minimal configuration. So when we go back to our Docker file example, right? So let's go back to our Docker file really quickly. Let's go to Plumie GitHub. Now, these aren't exact comparisons because they are two different types of repositories. However, in the just simplest scale of lines, let's look at what we achieve with both. All right. We have a from at the top, which is one line, right? But it gives us every single package from that from. We have no way of declaring where that comes from or what version it is or anything like that, right? It's just from. It's a blanket, give me all packages scenario, right? Whereas here, we are more declarative about where our packages come from. If we go back to our chart, which I'm going to show one more time, remember the from is what manages our packages in a Docker file, but Nix only cares about our packages. It doesn't care about the operating system or anything like that. And so because of that, in a Nix world, we have to tell it where all of our packages exist, right? Here we don't. Here we just use a from and we try to. Now, if it doesn't exist, what do? We do things like this, right? So if you go BG, okay, cool. You're making it off of the assumption that everything exists in this. Okay, cool. Well, no, if that's the case, then look, we have to add this. Like, for example, I didn't have Doppler as a package available to me in this image. So what did I have to do? I had to run extra commands to set up that repository so I could install it, right? Same thing with just. Just is installed via an actual script. So I had to use their script. Whereas here, all the same. You have to use inputs like this. So that means that if I needed a just input, right, I would say just file.url, right? If I needed a Doppler one, that would be doppler.url, right? And that's how it would work, right? Or I would use it from one of the existing inputs, right? Maybe Nix packages already has Doppler. Here, let's go take a look. Nix Doppler. Sure enough, it does. Cool. I could just say, all right, well, if I want that package, I'm just going to say packages equals Nix packages dot system dot Doppler. Now, again, I don't have this variable here because it's not inside of a function, but if it were inside of a function, that's exactly how I would get it. Or if I wanted to here, I could then say Nix packages, system Doppler. And that would work because system is available, Nix packages is available, and Doppler is available inside of Nix packages. Does that make sense? Cool. I don't want to lose all of my other work, so I'm going to save that really quickly. And that's it, right? So Nersk, whatever it's called, has a package definition inside of it called build package, which enables us to use that function to build our packages. And again, if we go back to the example that Scotty gave us, right? And you're going to see this a lot. Like you are going to see this a lot with Nix, where a lot of things are named similarly. Like a lot of these like utilities and libraries that are out to help are kind of honestly rebuilt. And I think that's another thing a lot of people who are in the Nix world might be able to also say too, is like, there's a lot of things that are kind of just slight variants of other things, where they kind of do the same thing, but they've, because we're all spread out in the Nix ecosystem, I don't think we're as collective. And so, for example, like Dream to Nix, that's a really big project that's trying to solve that, where instead of having like a bunch of different build inputs for like a build input for Node, a build input for Python, a build input for this or for that, Dream to Nix basically says like, we can understand what type of packet or what type of program this is and build for it. In this case, though, we're not using Dream to Nix. We're actually using something that only builds Rust packages. So what does that mean? That also means that I could not use this with a Python application. If I tried to use NERSC build package within a Python application, it would fail, right? So that's the caveat here is I would need to find another way. And actually, to give a better example of that, if we go to Nix, there should be an example Nix Python from that YouTube video. And if we go to the flake.nix, you'll see that in this flake, we use poetry. So default packages system, just like before, poetry to Nix, and then bam, make poetry application, right? And that's because if we look, inputs Nix, poetry to Nix is already a package in Nix packages. So we don't need an input for that. And that's what I mean when I keep telling you that like these flakes are highly reusable, right? If I have a flake, I can have packages inside of that flake that I can reuse. So I only need the input if it doesn't exist anywhere else. Cool? Cool. Okay. The next thing to talk about really quickly, now that I've given you a crash course in packages and basically how that declaration works, we're going to talk super quickly about dev shells and apps. Dev shells is basically what it sounds like. In a Docker world, right, your dev shell is really your Docker image, right? So what you do is you write this Docker file, right, and you put everything inside of it, you copy all your source code, whatever else you need, you do your npm install, whatever, and then at that point, you Docker container run into it, and then bam, now you're using your Docker container as your dev environment, if you wanted to, right? I'm just saying that's what you could do. With Nix, Nix is entirely shell-based. And what I mean by that is Nix goes out, builds all this stuff in what's called your Nix store. And if you're curious about that, guess what? I got another YouTube video for you. On our archives, we actually have, so the second link here, on our archives, come on, wake up, Quirk. There we go. On our archives, we also have a section that is entirely dedicated to Nix and VODs from Nix. So if you check out the archives and subscribe to that, you'll also be able to go to like the playlists or just scroll down a bit. And you'll see that I talk about Nix introduction, basics of the Nix language. I talk about the store and garbage collection. The main idea here is that Nix is a bit like Homebrew, in the sense that when it builds packages, it builds them locally in its own specific folder, right? And then it symlinks and puts references in your path to all of those specific binaries, right? So in a in a homebrew world, right, you're probably used to it, symlinking and a bunch of that, and then basically saying like, okay, cool, I have all of my programs available to me. In a Nix world, it builds a shell with all of those in your path, and then that's how you run those programs. So for example, if you were to say like, well, can you show me an example of that? I can. If I go to where is nvim, you'll notice that my NeoVim actually exists in what is called the Nix store. And that's what I'm telling you when I say that Nix creates shells for you with everything you need inside of them. This is another reason why you might like Nix, because Nix doesn't require containers or virtualization or anything like that. It is literally building all of the packages you need on the operating system for you, and then making those available for you in other packages that you're trying to build, right? And it's doing that for me with NeoVim and my actual programs that I'm trying to build, and the Rust program we're trying to make right now. Yo, the Ida Allen, what is up, dude? Thank you so much for the raid. How's it going, buddy? Shout out to the Ida Allen. How are you, my friend? There we go. Nix and Rust. After an Ida stream, Rust, it is Christmas. Well, I hope you enjoy it, man. How was your stream, the Ida Allen? How are you, buddy? How is everything? And Alan said that Alta 4 guy. Oh, wait, sorry, wrong chat. Plus, it's a, by the way, Neuron, how's it going? And Cryogi, hello, hello. Plus, if it's a security concern of views, you can have it do all of that completely from source. Yes, yeah. And that is another thing to note is it is building these packages, meaning it's not going out to try and find, pre-builds, or, well, it might, but that's only, that's caching, and that's something later. Don't worry about that. Checksums are awesome. That's all I have to say. But what I really am saying is that in a normal scenario from scratch, it's going to go out, find the source code with that flake that it contains, right? So that's why it's really important having these flakes, right? Because if I didn't have this flake and somebody tried cloning my repository, Nix wouldn't know what to reference, right? So that's really the way that we share flakes. If you're like, well, is that how that works then? That is exactly how that works. You have Git repositories that have flake definitions inside of them, and that is normally coupled with your source code. But it doesn't mean it has to be. I'm just simply saying that that's normally how it is, as an example with the Rust application that we're trying to build here, right? Okay, so we're going to set up, just like we set up a default package, right? We're also going to set up a default dev shell, right? And as I said before, Nix separates itself from the operating system, right? So just like we did with packages, where we say for each system, we want to use the NERSC version of that system's build package, right? So that's literally what this means. We're using the NERSC library that supports this specific architecture, right? x86-64-Linux, x86-64 Darwin, whatever, right? So that means that NERSC also has a place where it defines build package that can be built for all of these different systems, right? And so because it can be built for the architecture that we support, right, we can then easily say, all right, we're going to follow that same convention and say we want to build a package for this system using that function that is for that system, right? And then we build it from our source code, right? Dev shells works pretty much the same. We want to make a shell, a dev shell, that is our default shell for the specific operating system. Now, if I went up here and I removed all of these and then I tried building a package or executing a dev shell, right? Then none of it would work, because I'm not telling Nix which architectures or systems it can build for. That's why it's crucial to not only have the supported systems you want to build for, and then have some way of being able to easily reuse that. This is why we have the for all systems here, is again, we use supported systems, we get all systems that we support, and then we start generating lists of things. So for example, we do for all systems, which is our function, right? And then we say for all systems, we then get that function, and then we say make or return the Nix packages legacy packages.system. That becomes all of the packages for that specific system, right? And then NERSC, we do the exact same thing. And that's why we can do the NERSC blah, 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 right? So again, it's just a convention that's being reused so that we can target every supported system we're trying to build for, right? You could really read this also, basically just packages.make shell. Again, this part here is just for the support of the specific system. So we're saying dev shells for my specific system, create a default shell, and make a shell no CC. Don't worry about the no CC part. Honestly, if you really wanted to, you could just say make shell. But what we're really simply doing here is we're making a new shell. That is it. We are simply just saying that the dev shell that we want to build should return a shell, right? And inside of that shell, we do a few things. First, we set the Rust path. Now, you might look at this and go, why is this in full uppercases, but then this is in lower cases? Now, there's another thing about Nix, especially with building, which is whenever you build, each one of these parameters become available inside of the actual shell of the build. So technically, build inputs and native build inputs are environment variables in the shell, just like Rust source path is, as well as some other things. And I could show you that once we're actually in the shell. But we're doing the uppercase because this is an actual Rust environment variable that we want to give to the path of our Rust lib source, right? Rust has lower level libraries that it depends on. However, this is a new shell that has no concept of those libraries whatsoever. And so what we're doing is we're saying when we make this shell so that Rust works properly, let's also make sure to link the library source within the shell environment so that when Rust runs, it knows how to reference those Rust platform libraries from the Nix store, right? And again, I'll show you that in a second. Build inputs is specific to basically the actual command line utilities that you feel you might need commonly. Like these are like utilities and things like that. So these would be like formatting tools and other stuff like that. There is another big difference between build inputs and native build inputs, and it's basically their injection at build time, and basically how they're injected. Build inputs are again more like command line utilities, whereas native build inputs are more meant to be like libraries and things like that. So like realistically, I think it would probably look more like this, right? You'd probably put like Rust C, cargo, and Rust format there, and then you'd have like GCC or libconf. Maybe even GCC could go up, or like libconf. But yeah, basically that's the main point. I'm not really using that very heavily right now. I think I'm just following whatever was in the tutorial. So these aren't probably organized as well as they should be. But the main difference between build inputs and native inputs, as I said, is just these are like the command line utilities that you would be running commonly. Whereas native build inputs is more focused on like the libraries that those command line utilities need and things like that. And then that's it. That's our dev shell. So what does that mean, chat? Again, if we're comparing this flake to the Docker file, well, again, with a Docker file, you don't have to declare the shell. You just make the Docker file and then run the image, right? Whereas in a Nix world, we just say, not only do we want to make sure that we tell it the output of the packages that we're trying to build, right? But we can also tell Nix about the dev shell environments that we want to build too. So to quickly show that to you, I can just do, if I go, let's move this off screen. If I go here and I do Nix develop, right? If I just run this, what's going to happen is it's immediately going to go out and it's going to build this shell for me. Now, the first thing you'll notice is that it's fetching some sources, and then it did a whole bunch of like evaluating, and then bam, now I'm in a completely shell. And it's a different shell. As a matter of fact, you might notice my prompt is even different, right? Why is my prompt different? Well, that's because when I created Nix develop, I'm in a completely new shell now. I'm not using my previous profile or anything like that. However, if I did echo Rust source path, look at what the Rust source path is. So that's what I meant when I said that those environment variables or those configuration values in the configuration of the dev shell become environment variables. They do. And if I do like echo build inputs, oh wait, whoops, forgot to put a thing in front of it. Bam, look at that. There's Rust format, right? If I do echo native build inputs, look at that. There's Rust C, there's cargo, there's GCC, there's libconf, or GC lib IC, whatever, iconf or whatever. That's that's the power of Nix, is like it knows how to link in those environment variables the paths of what you need. So if I wanted to make this so that Nix develop would also like give me my shell, I could just do this and then shell, and there you go. Now I have a shell of my own. But now I can also do Rust source path, and then there you go. There's the environment variables for that. And the same thing here. We do build inputs. There's my build inputs. And then if I do, again, native build inputs, there's my native build inputs. Now, if I leave the shell, I do echo. You'll notice that I can't even tab it because it doesn't technically exist in my shell. But if I try and copy and paste the whole thing and then do it, you'll see that I have nothing. That's because I'm no longer in that shell. I go back to it. I'm back in that shell. This is what I mean by, Nix doesn't require any kind of virtualization. All we're doing is we're building the packages that we need. We're adding them to our shell, and we're running them. So if I did where is Rust C, for example, look, there's where Rust is. Rust is in my store. Right? Okay. So that is a dev shell. All right. So let's do one last thing, and let's look at the third declaration, which is apps, right? apps is basically apps is basically doing the same thing as dev shells and packages, right? But we're telling the flake what programs it contains itself that you can run as like an actual CLI or like run as a program basically, right? And so you'll see here, that's why it says default and then program, right? And what this means is that this actually makes it so that I can do that run neofetch thing that I showed you before. Nope. Neofetch. Nope. Here, let's try this. Nix. There we go. Yeah. So you see here where I say Nix packages neofetch. When I said that this is a package, it is. However, it's also an app. And so apps make it so that you can run them as programs, or basically their build outputs as programs with Nix. And it'll make sure to build it. So if we look at this a little bit closer, right? Apps pretty much does the same thing as dev shells and packages for all systems. We know what that does. We know what system is here. We know what default is, right? So the only thing that's really different here is the program. Now, as I said before, you can reference flakes and get values and attributes from them, which also means that you should be able to reference yourself and get attributes from your own packages if you need to. And if you've ever worked with like Python or JavaScript or anything like that, self or this might you might notice that. And it's the exact same thing here, right? If you look at the top, you'll see outputs self. The first parameter that we grab is literally our self. And so what that means is that anything that we declare within our own package, we can now use elsewhere within our flake, right? And so what I'm doing is I'm saying, hey, app's default program is actually the package that we build here. Self.packages.system packages system, right? Now remember, we said that default does not, oh wait, no, never mind. We do it here, my bad. But it doesn't have to be used in all places. I use it here to be explicit, but I actually don't think you would need to use it. I'm not 100% sure if you would need to explicitly use the default here or not. However, because I'm explicitly doing it, it makes sure that packages.system.default is used. And so what is that going to do? Well, first, when I go to run this app, it's going to check to see if this has been evaluated and built. If it has, we don't do anything, right? Nix is lazy loading. It's cached. So if it's already been built once, we don't have to be worried about doing it again unless we make a change, right? Otherwise, if it hasn't, it builds it first. So it goes, okay, got it. I see this doesn't exist in the Nix store. Let's go build it real quick. So then it builds it, right? And then what it does is once it builds it, it exists in the Nix store as a program too. So your program gets built and is then added right next to every other program that's been built in the Nix store, right? That is the Nix store path that is provided here. Basically, this variable gives us the path of the program that we build. And that program that we build, self.packages.system default, is our package. So basically what we're doing is we're adding our package to the path of as the program, and then we say bin build configs, right? Because that's the actual name of the binary that'll get generated. And then the type we tell it is app, right? So just like with Nix develop, where I did the Nix develop -c shell, what I can now do is Nix run dot, right? And if I just do that, it will run the program. And as I told you before, if we change anything, it has to go back out and rebuild it. And because we've changed source code for the application underneath, look what it's doing. It's building the dependencies for all of build config deps. Look at that, compiling clap. Right, it's getting all the build dependencies it needs. And then here we go, build configs requires a subcommand that was not provided. It ran my program, right? So it went out and built it, right? Or it evaluated it. It went out and built it if it has to. and then it runs that built piece of software from the Nix store as if it was being directly ran as the binary, because it is. We declared the binary to run. So I can now, if I wanted to, if we're saying like, okay, BG, well, what does that mean? What does that entire build process look like for you? Well, I go into my application. I make some changes, right? Say I make some changes, add some lines. I save that. I immediately want to try it. I run it. It's going to rebuild it, and it's only going to rebuild what it needs to. So if there's any other things that it doesn't need to rebuild, it won't. And that's why this was much quicker the second time around, because we didn't have to rebuild the dependencies or any of that kind of stuff. That already exists in the store, right? Okay, cool. Let's do it again. Cool. Made some more changes. Nix run. Instantaneous. Now, why was that instantaneous? Because both versions exist in the store. Right? There was a version I had where all of those lines were there, and then I had a version where all of those lines were not already there. And I told you Nix is lazy. And so because of that lazy loading, I should say not lazy, it's lazy loading. Because of that lazy loading, it only has to build and run the things, or it only has to build the things when we actually get to that, you know, that change. And so now if I want to run it a bit more, I could say like, Nix run dot dash dash generate. And so if we do dot, right, this is going to run the flake. And if you do space dash dash, this allows us to actually pass the commands that we want directly to that new shell. And so now you can see here, if I do dash dash generate, we actually see none, right? And there you go, chat. That is an overview of how you set up a Rust package with Nix. You build it, right? You set up a dev shell for it, and then you also set up the application and the path to it so that you can then run that and have that like complete development loop. Now, if you wanted to as well, right? I just showed you how to do nvim and then make a change, right? And then build that and run that with Nix run, right? However, we still have our dev shell that we're not even using, right? Like if I do echo Rust path, right? I'm not in my dev shell. So how can I also use my dev shell for that development process? Well, I can do Nix develop shell, right? And at this point, I now have cargo available to me, right? So what does that mean? That technically means that if I wanted to do a cargo run, I can just do cargo run. And then bam, I can now run it just like I would with cargo, right? Dash dash generate. Oh wait, no, sorry. That's right. I don't need that here. Generate, right? Unrecognized. Oh, whoops. Sorry. I don't need that. There you go. Bam. See? Now I'm able to run it directly with cargo if I wanted to, or if I want to run it with Nix, I can do that too. Cool? So again, what did we do with our flake today, chat? We set up first and foremost a very simple Rust project. Again, with a basic cargo.toml. You know, we have a very simple main file with some code in it for setting up our CLI tool, right? We then created a flake file, right? So we create a flake.nix, and inside that file, we provide inputs of all the packages and where we can get them from, right? We declare some variables for our flake that we need within it. And then we start declaring our packages, our dev shells, and our apps, right? And our packages is what the actual piece of software we're trying to build, its definition exists, right? And we said that really the only lines that are specific to Rust are these 3 lines here. If we were trying to build for Python or anything like that, this would just be a different function being called with default. That's it, right? So it would just be Python build or something like that. You know what I mean? Dev shells, right? We said that dev shells build for all the systems just like the packages do. And we can provide it with environment variables if we need to, as well as the build inputs and CLI tools and everything else that we need with it as well. So that when we go in and we run Nix develop, right? Nix develop like this, I should be able to do echo Rust source path and then see that source path in that shell, right? Cool. And then the last thing is the apps, where we said, all right, well, we want to have this like complete cycle with Nix where we can, make some code changes and immediately run that and make sure that it's built, it builds properly, everything is fine, right? What we can do is we could say, all right, we want to have a default app, just like we have a default dev shell and a default package. And that default app is our actual application that we're trying to build, right? So self.packages.system equals packages system, right? And then .default is the default package that we're building right here. And then because it's going to be put into a bin and then build configs, the actual binary that we build from Rust will exist here. This is the full path that we tell Nix to run after it builds the package. And why does it build the package, chat? Because it's declared here. Nix will evaluate this and will say, all right, well, have I built this yet? And if it has, it automatically knows to continue and just immediately run the program. Otherwise, it stops and says, all right, nope, we're going to do this first. And then we're going to come back here and we're going to inject the build output path from this to this path and then run it, right? And so that's what enables us to do, again, Nix develop. If we want to develop within our Nix shell, right? And then do cargo run generate like that. Or if we leave, we want to do Nix run directly, we can do that, and we can run that without having to actually go into our dev shell. And there you go, chat. That is a breakdown of how to set up a Rust project with Nix. If you have any questions, feel free to let me know. This will be a VOD. We will be uploading this to YouTube. It will be in the archive. So remember, subscribe to both of the YouTube channels. I will also be, again, putting out a new video soon on what Nix is, and again, a bigger breakdown of all of that kind of stuff. So again, look out for all of that goodness. Do you have any questions? Does anyone have any questions? Got to rate and run. Oh yeah, no worries, buddy. Sorry, I know I went off on a tangent there. Wait, for all system really as simple as redefine call generator. Are you actually calling it for each one? Ignore me. Oh no, you're good, Nero. You're good. Sir, what is up, dude? To Wildfire, I love you, bro. I love you too, bro. I appreciate that. I appreciate that, bro. Oh. Cool. No questions. I like it. All right. So what are we going to do? I'm just going to commit this, right? Now, there's one last thing I guess I could show you really, really fast, right? And that's going to be the flake.lock, right? Now, I told you when we build or when we use inputs, they are locked to their version. And so you might say, BG, well, what exactly does that mean? Well, when we lock flake utils in our flake file, right? Here, flake utils, just like a yarn.lock or a package, a package lock.json, right? Just like those files, Nix also generates its own lock file, right? So what that means is that this file declares which version of flake utils we're using down to the revision or SHA, right? Does that make sense? And so until you update this, or Nix does, which it can for you, you just use Nix flake update like that. Oh, Nix flake update. There we go. It will now go out and see, look, it updated Nersk because I guess it had new versions, and it updated Nix packages because it had new versions, right? And so now if I go back into that flake.lock, those will, look at that. See, I have changes for Nix packages as well as, oh, I guess maybe it was just Nix packages. Oh yeah, I guess it was just Nix packages. Looks like Nersk was already updated. But yeah, you can see the changes that it updated it for you. So you don't have to actually, come in here and manually do this. Nix can help you with that. But it will make sure that, it will make sure to version lock it down to the SHA so that it won't change. And what does that mean, chat? That means, and again, this is a massive difference. So again, I'm going to go back to Pulumi GitHub, and I'm going to open up that Docker file one more time because this is one of the biggest differences. Actually, it's over here again. In this Docker file, Docker has no concept of this. Now, Docker, maybe at some point it could like find all of the packages and then like make a JSON lock of some sort. But until Docker can do that, it cannot compare to the true reproducibility of Nix, because Nix locks every version of every package down to its SHA. Like we said before, Nix packages is where all of our packages comes from, right? So if all of our packages comes from Nix packages and we're only getting it from revision 2, 3, blah, 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 I might be able to install a bunch of different packages, but I won't be able to install them that are any newer until I update the flake lock file. Does that make sense? Right? So that is a massive difference between Docker and Nix, which is Docker just takes the from and will always install latest, essentially, right? Whereas in a Nix world, the only way you'll ever get latest is if you run Nix flake update and get those latest SHAs added to the lock file here. Then it will install the latest packages for you. Can you do a video on creating a flake to build systems? Build systems in what sense? Day, what do you mean by that? I want to install Nix on my OS now. Do it, man. You should. Again, check out the YouTube videos, man. There's some really good stuff out there that, you know, we've already made that can be really helpful. And again, I am also going to be releasing at the end of this month a new YouTube video on what Nix is, and I think it'll be a really great crash course in getting started with Nix. I still haven't committed to running Nix on my main OS. I probably won't commit for another 3 years. That's fine. I have no expectations of time. It's all clear. Just missed what. Where is the specified commands to actually build the Rust source code? So that's in Nersk, right? So when I say Nersk, N-A-E, Nix, Nersk, yeah. This is the flake that we're using to build Rust projects, right? And so we are using a different flake and its commands to build. And so you can see here, Nersk is then called with build package. Well, if we wanted to, we could probably go to default, build package. Boop, there it is right there. And then there you go, inherit build package, right? So it's exporting the build package function that's being declared right here, right? So if you were really like, okay, where's it doing it? It's all right here. So this is more Nix code that, and this is where you kind of start going down the rabbit hole. I'm going to be fair, Cosmo, and for anyone else interested in this. Nix is just functions within functions within functions within functions. So what does that mean? It means technically there's probably a function like build package that's calling another already existing function. And it is, I know it is, it's calling, let's see, build. And if we look at build imports build.nix. And so if we go to build.nix has got a ton of things that it has. Because remember, we're trying to build any type of, you know, Rust application here that we can. But if you look here, we keep going down. See, you'll see these common like native inputs, build inputs, all that stuff, right? Look at this, configure phase. So this is where you'll start seeing things that are specific to like building the application itself. Now, this is, again, I'm going to be making another video on this, so don't worry. Within time, I will show you. But basically, Nix builds things in phases, right? So it builds things with like configure phase, install phase, check phase, doc phase, right? And so what it's going to do is it's going to enable you to have all of these phases that you can use to build your code. And so that's what Nersk is doing. Nersk is leaning on the phases that Nix used to build software. And it's saying, okay, we want an install phase, we want a doc phase, we want all these other phases. And then it's going to run these phases in one primary like job, essentially. And so, you can see here like name, post build, right? And then it'll run all of those things or, you know, whatever as well. So if you really, really, really want to get down to the like the nitty gritty of how something is being built, you normally need to go to its flake and then look at, you know, either a flake within a flake, within a flake, within a flake, within a flake, or, you know, you'll eventually get to the source code. So technically, and again, this is what when I say the word derivation, this is truly what everything is in Nix really is. Everything comes down to what is called a Nix derivation, right? And so the derivations in Nix it's the most important build function because it's what actually tells Nix that this is a program and a specific version of a program that you need to build, right? And so there's thousands and thousands and hundreds of thousands of derivations that can probably exist on your computer at any given time for all of the software you need, all of its dependencies, and they all live right next to each other. And so what that means is that if I go to Nix store, here they are. So you'll see bash right next to Python, right next to bind, right next to K9s, right next to Perl. Like they're all right next to each other. And so if I go to K9s bin, there's the K9s binary, right? All that kind of stuff. I hope that makes sense, Cosmo. I don't think Docker will ever will. It's too low level and we'll expect. I don't think so either, Tani. I don't think so either. To be completely fair with you, I don't think Docker will ever do that either. I think it would be too difficult to actually implement with Docker. Yeah. OCI image signing, including the lock file. Yeah, I mean, like image signing is close, right? Like image signing is probably as close as you can get to like this is what I want and expect, and this is how I'm going to expect it, right? Is by using a SHA or something like that. You can use Flakes to install on new computers. You can use Flakes to install on new computer systems. Yeah, we'll take a YouTube VODs. Yeah, check them out, man. Check them out. What do you mean by that, Dave? You can use Flakes to install new computers. Yeah. So you're talking about NixOS, Dave. Oh, yeah. I believe you're talking about NixOS. Yeah. And I will do a video on NixOS itself. Yeah. You should look into Nix packages official builder for Rust. Narisk is obsolete by many things stuff these days. Nix part / I mean, just send me a link, Cran, and I'll take a look at it. What is this you sent, Agile? As for project wears on standards, sets will slip lower zeros. Okay, maybe I should be able to dual boot BSD soon. 6 hours. I'll be helpful if I can get the system. 24 hours if we're lucky. The sharks will stay. I love that. That's great. Yeah. NixOS. Yeah. I'll do a video on NixOS. I have one planned. Speaking of Flakes, do you suggest using Flakes to also build your system? I use Cran, just send me Cran, I can't right now, buddy. Just send me a link to a example of the thing you want me to try. But if you can do that for me, I would greatly appreciate it. Because somebody else told me to use Crane earlier, which, I'm not against trying. You're telling me to use I'm going to be real. Like there's a bunch of people suggesting a bunch of different things. So what I'm using right here is just what I got working. And again, it might be old, but at least it works. You know what I mean? So yeah. And I have said, you can try there's other things out there that solve this problem. Yeah, you're good. You're good, Crane. You're good. All right, guys, check it out. I got to get going. I got to get to work. So this is the first part of building this Rust application. We actually did not do a lot of Rust today, surprisingly. However, we did spend most of the stream sitting down and taking this from a DevOps perspective, right? And that's why I really wanted to try and exemplify to you guys why this is a DevOps problem that we're solving with Rust, right? I like Rust. I think it's a really cool language, and I think it's got a lot of really awesome capabilities. However, I don't normally jump into something, at least until I really find a use case for it. And Go was like this in the early on as well, where when I was using a lot of TypeScript and Node, I really didn't have a reason for using Go. Go was a brand new language. It wasn't as disruptive yet. And so it took some time. And then once Go started becoming a part of my development process and stuff like that, I was able to start using it more and utilize its benefits. And I think Rust is, kind of one of those languages for me too, where I'm definitely interested in it. I definitely want to build some cool stuff with it. However, up to, certain points, it's been hard for me to distinguish, like, okay, why couldn't I just build this in a different language, right? And there are massive benefits to using Rust that I am at least aware of. A lot of it has to do with memory management and things like that. Those are the real powers of Rust and the cool things you can do with it. However, maintaining it as a normal language is also something that's just interesting to me, because I always try and use this comparison, like, sure, you can build things in one language, but at the end of the day, it doesn't really matter what that language is as long as you're proficient in it. You know what I mean? You can be a complete Rust developer and build most of the things you would need, just like you could build it in Go. Like most of these languages are what we call general purpose languages. General purpose language means is that they have general purpose to them. You can use them for pretty much anything. You know what I mean? Compared to like a domain specific language, which is what Nix is. And I want to be clear with that. This language is a domain specific language. If I use a variable like this, it will return a path for me. That's just the Nix language and how it works. So I do want to be clear that, that's a difference with a general purpose language is, you have general expectations around it, whereas a domain specific one's for domain specific things. And so because of that, we looked at our problem, which is we maintain a large amount of repositories which contain similar build configurations that require us to manually update each individually when changes occur, right? So again, the idea here is that we have hundreds of repositories that, we all want to be able to update the build configs, the Docker files, the Circle CIs, the whatevers. But every time we make a change, we need to change it in every single one of those repos. We need to make sure that that change is consistent, that it's working, that we have good expectations around those changes and all that kind of stuff. And at scale, that becomes very difficult. So when we talk about what we have with regards to those repositories, we have Docker specific repositories, things that are just only focused on building Docker files, no languages or anything like that. We have Pulumi repositories that have Go or TypeScript, but between the two, there are also things that configurations that work with both. So for example, Circle CI, Docker Ignore, Justfile, and Pulumi, these are not specific to Go or TypeScript. So these can be a generic template for Pulumi, whereas like gitignore, Dockerfile, tsconfig, these are all language specific. And so maybe if we have a Pulumi template, there might be also sub-templates that are language specific, so that we give the exact type of templating that we need to generating these files, right? We also have services, so like Quirk, a whole platform that we build called Quirk. Remember, if you guys do like Quirk and chat or anything else, that's our bot, that's everything that's powered. This is all as well, applications, Node.js, TypeScript, Go, right? All that kind of stuff. And so we're going to find ourselves in a similar scenario where like, okay, TypeScript will need these files, right? Go will need these files. And another thing that's really powerful about this is if you think of Quirk as an entire platform, and we say, all right, we want to move all of Quirk out of Circle CI or something like that, and we want to put it on Hercules CI, or we want to use Nix going forward, right? This is what's going to empower us to move our whole platform from one build configuration to another, right? Because we use the CLI tool. And that's really why this is heavily important. Because if we say, all right, well, all of these use templates, and we just update the templates to use Nix to build our systems instead of other things, then all we need to do is go out and generate all of the templates in all of these repositories, and now we've just moved our entire platform from one CI system to another within a matter of like minutes. Seriously, and so that's why this tool is so powerful, and to think about what we need, right? Same thing for, again, anything we build going forward. We talked a bit about the repository configuration and how we want to approach this. So we're gonna have a basic name, and that's gonna be like our build name essentially, right? And this is really going to be what is used in CI, what the binary we're going to get, all that kind of stuff. The build language, right? And this is really going to be what language is the software built in. And then this is the build templates, right? Pulumi, the type, right? And so the type as well as the language really help us understand the overall templates that we're going to use, as well as the language inside of those templates. And then we talked a little bit about the third and final thing we need, which is a redistributable CLI, right? We don't want to have to lean on something that has to like make us ship packages with it or things like that. We would much rather have just a very simple binary that we can just ship and everything goes with it. You know what I mean? And we talked about two languages in particular that I would consider to build this tool. The first one was Go. The second one was Rust. Now, as I said before, between Rust and Go, there's a lot of similarities when it comes to building a CLI tool like this. Like, again, you have to objectively look at what you're trying to build to compare it to another language. You just can't compare two languages together and be like, hey, whatever, you know? You really have to say like, okay, what are you building? And is in the comparison to the other language, how does it run? Like, how does it work? You know what I mean? Then you can get a better accurate, you know, assessment on like, is this better to build this in this language or in this language? And again, between the two, it's very similar. Go, you can build to a binary, it's easy to maintain, and you also have a fast and efficient, you know, way of running your software. Builds but to a binary, easy to maintain, fast and efficient. Same for Rust, right? Very similar in that regard. The two things that were differing to me, and this is really unique to Rust, or I'm sorry, unique to Go, I think, is that Go has a built-in templating engine. So a lot of things out there just use that. They don't have like Jinja or handlebars or other kinds of templating. When we say templating, we literally mean that. We need something that we can just template files with and inject variables into, because that's what we said we wanted to be able to do above, right? We want to be able to have these templates and inject the build name, inject, you know, specific files or options based off of the language or the type of template. And so if I wanted to do this, it would probably make more sense logically for me to just use their templating engine. And we even looked at that, and I kind of showed you where it was limited, right? Where it was limited and how it's a bit more general use focused, and not so focused on just purely being a templating engine itself. However, with Rust, because Rust doesn't have a templating engine, there's more options out there available where we can use like Jinja or handlebars or stuff like that. And so because of that, that was another thing that just made Rust a little bit more attractive. Is I didn't want to build something in a language that like really it wasn't preferred, you know? And Go does have a templating language of its own, so we're gonna write it, you know, we would probably have written it in that language. And again, another big advantage is that here's what we can say too: knowledgeable, and then this will say beginner / learning, right? And this is probably, you know, the other last thing is like, I really wanted to get more comfortable with Rust. I have a decent understanding with it and how to get it, you know, started, but I wanted to get a better understanding of the language at a much lower level. And so this here was probably really the deciding factor more than this. Right? For me, the built-in templating, I could have done it. I would have had to work around it, and I probably would have hated it in some ways. But this would have meant that I would have built this the day we streamed it. I'm going to be clear. We would have built this the day we streamed it if I would have built it in Go, because I'm so knowledgeable in Go. I've been doing a lot of Go lately, and I've been writing Go for quite some time now. So like I can build Go applications pretty fast now. Rust, however, because I'm beginner and I'm learning, it definitely made it a little bit more like, however, this did give me an opportunity to learn the language more, which is what I'm excited about. And I get to use Nix, right? And we are going to build this entirely with Nix. Like I'm not going to use Docker or anything like that. So that's another cool thing is this is an opportunity to learn and get myself even more further into the Nix door, because as you can tell, the Nix approach is like Nix and Rust work very well together, and I like that a lot. So again, that gives us another opportunity to use Nix more and build it more in our systems and stuff like that. And again, this will be a Nix package at some point potentially if we open source it, if we open source it. But all right, guys. Well, thank you so much. I really appreciate it. Again, today was an awesome opportunity to be able to sit down, show you what we're building and why we're building it, break it down from a DevOps perspective, give you an opportunity to be able to, figure out how to tackle these types of problems and solve them. And then as well, I showed you guys how to set up I'm sorry. Yeah, buddy. Neon, I am sorry, buddy. I got to get going. I'm literally about to hit my 4-hour mark. But hey, listen, Neon, and for any of you else, join our community, man. This is a little bit about us as well as our Discord. Check out our YouTubes. Our YouTube has got both links. The first one is our more curated content. Again, at the end of this month, I'll be putting out a video on what Nix is, so be sure to subscribe to that. The other one is our archives. Be sure to check out that. That has a bunch of already VOD-related content of Nix, so be sure to see if you might have something there you're interested in. And yeah, check out the social media as well on the Twitters and whatnot. But yeah, thank you guys sincerely for hanging out with me today. I really appreciate it. I hope you enjoyed, again, the whole process, right? This is a day-to-day for me. Sit down, break it down, figure it out, think about what we need, start implementing it, and start moving forward. And so I feel really confident about this. I feel like I know what we need to build now. I feel like we also have a really good setup for building it in Nix. I think I was able to give you guys a good opportunity to understand that. I'm going to get these VODs uploaded before next stream, so that next stream when we talk about it, we can reference these VODs, okay? So I am going to make sure that we do that before next stream as well. But yeah, thank you guys again so much for hanging out with me today. I've already given you the link, so you pretty much already have that. Let's go find somebody to raid really fast before I head out of here. I hope you guys enjoyed the stream too. Again, next stream will be much more focused just on what's it called, on programming in Rust itself. This was more getting it set up and all that kind of stuff. Have you checked out Backstage? I have. Yeah, I've had a lot of people suggest Backstage to me. It's cool. I think it's a really neat piece of software. I've not fully used it, so I can't like give any recommendations on it, not to be honest. And I really don't try and do that unless it's something that like I think people would be interested in or something like that, or not interested in, but that I can say I've used and you might use it too. I just need to try it. I honestly do. I just need to try it in all seriousness. Okay, so we just raided Fooney the other day. Yo, we haven't raided Trash in a while. Let's go raid Trash. Let's go say hi to the homie. Let's go raid Trash. Let's go say hi to Trash. All right, guys, listen. We're gonna go raid Trash Dev. If you guys don't know him, he's one of the homies. Seriously, we've hung out with this man. He's fantastic. He's such a good dude. Let's go give him some love. Let's go say hi. Everybody jump in on this raid. Have a very, 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 very fantastic rest of your day. I appreciate you. Again, be sure to check out the Discord. Here you go, Discord, the YouTube, the social, all that stuff. Be sure to check all that out. Go say hi to Trash, by the way. Jump in on this raid, guys. And yeah, have a very fantastic rest of your day. I'll be back Friday. So I hope to see you guys Friday. And yeah. Enjoy yourselves. All right, guys. Have a good rest of your day. Peace out.